everyone, how are you? So welcome back to this LangGraph class course. In this video series, we are going to learn LangGraph from beginner to advanced level. We will understand LangChain, what is LangGraph, what is chains, what is agents, and states in graph, okay, and nodes and edges, memories, agents, multi-agents workflow, and real AI project with the help of LangGraph. Okay, and by the end of this course, you will be able to build your own AI agents and workflow. Okay, so watch till the end. This course is beginner friendly, so even if you are new to LangGraph, you can follow. Okay, so now let's start. So you can see here, this is our course overview. We will understand here what is LangChain, what is LangGraph, difference between chains and graphs, nodes and edges and edges, conditional routing, memory and persistent, multi-agent workflow, and real AI project using LangGraph. Okay, so we are going to create 2 or 3 project in this video. We are going to cover. Okay, so now we are going to understand these thing one by one. Let's start. So here in the screen you can see we have one folder, LangGraph. In this folder I have virtual environment .venv. Okay guys, I'm not going to create it again. In last video I already show you this, okay, how we can create virtual environment, okay, and .env file. So this is our .env file. You can create env file like this, .env, for example, env, okay, .example. This is for example, okay, and you can put here API keys from Groq. I'm going to use Groq API key and what? Open router API key. Okay, so you can mention here Groq underscore API underscore key. Okay, and here you need to put API keys like this. You can go on Groq website and you can find out your API key. Okay, and put it here. So this is for example. I'm going to delete this file. Okay, I can okay, I can keep this file also here. Okay, and this is my first file 01 basic.ipynb. okay, so here we are going to cover basic of LangGraph. Then in file number 2, 02 underscore core underscore concept dot ipynb. Here we are going to understand core concept of LangGraph. And this is the file number 303 intermediate.ipynb. Okay, so we are going to learn here some intermediates of LangGraph. I will show you in detail after some time. Okay, and here file number 404 hands on build. Okay, so here also we are going to build something. I will show you after some time. Okay, and these are the project AI story weaver.py file and optional decision boat. This is also one boat. Okay, and optional research agent.ipynb. This is also one project. Okay, and smart underscore support underscore agent. Okay, so this is also project. So we are going to cover these 4 project 1 2 3 4 in this video, guys. Okay, and here you can see this is our requirement. So here you need to install LangGraph, LangChain, okay, LangChain, Groq, Jupyter, Python.env, that we can use we can access the API key from env file. Okay, and this is the Streamlit. We are after some time we will do the UI with the help of Streamlit, so that's why I use Streamlit here. Okay, and it is duplicate, so I'm going to remove this. Okay, and we have LangChain hyphen OpenAI. Okay, and OpenAI. If we use anything from OpenAI, then we need to install this. Okay, and here after this, I hope you have a Jupyter notebook. Okay, and then you need to open new terminal. Okay, here you can see I'm going to deactivate. Actually my virtual environment already activated. Okay, so now you can see it is deactivated. Here now I'm going to activate this virtual environment v. Okay, so I have commands for this. We can use this command. Okay, vnv/script/activate.psi. Okay, so we are going to activate. This is the script. Inside this we have activate dot web. Okay, so these are the files that we can activate our, with the help of this we can activate our virtual environment. Here now you can see here we have green sign here, and we have v. So here we enter inside the virtual environment. I'm going to clear this with the help of cls. Okay, now I'm going to install our requirement.txt, this file. Okay, so pip install -r requirement.txt. I'm going to hit on enter button. Okay, so it is going to install everything one by one. I already installed lots of things. Okay, so I'm going to close this. Now we move here in basic. So now we are going to understand basic of LangChain and LangGraph. Okay, so here you can see this is our ipynv file. Okay, 01 underscore basic dot ipynv. Okay, so first we are going to learn LangGraph basics. Okay, so here you can see what you will learn. LangChain, introduction to the LangGraph versus LangChain. Okay, and setup and installation. Okay, so here you can see first we need to understand LangChain. Okay, so what is LangChain? LangChain is a framework. Okay, we are going to build with the help of LangChain. LLM means large language model. Okay, so with the help of LangChain we can build LLM means large language model like GPT, Chat GPT, like Gemini, like Llama. Okay, so in here you can see in key concept agents. What is agents? Agents are AI system that can decide which tool to use. Okay, and they can understand the task, choose a tool and use the tool and generate the response. Agent can take decision which tool I need to use. Okay, and they also generate the response according to their decisions. Okay, so first this is the agent are AI system that can decide which tool to use. They can understand the task, choose the tool, use the tool and generate the response. That's it. Okay, and chain, what is the chain means sequence of the cell to the LLM or other utilities. Okay, or we can say here you can see this one. Chain is a sequence of the step, nothing else. Okay, chain is a sequence of steps. For example, we have input. Okay, and then we have prompts and AI models and output. We can connect it these things in a sequence. First input, then prompt, then AI model, and then output. Okay, so everything happen step by step in fixed flow. This is called the chain, a sequence of step. Okay, now we can understand tools. Guys, if you have doubt in chains, tools and agent, I already upload the video. Okay, I also mention video link in the description. You can go and check there for LangChain. Okay, so if you don't know LangChain, you can learn. Otherwise I am going to create basics. Okay, and here you can see tools mean function, Python function that agent can call to perform actions. Tool are functions the AI can use to perform the action. Basically, tools is a function, means Python function, okay? That agent can use these tools, okay, and generate the response. For example, search the internet, calculate the math, read the file, and get the current time. Okay guys, so यहाँ पर जो agent है, we have agent can use these tools, okay? User asks a question related to the internet things, then it will call the internet tool, okay? And if user asks a question to the agent some mathematic problem, then it will agent will use mathematic tools, okay, to generate the response for the user. Okay, so here you can see example of tool: search the internet, think, calculate the math, read the files, and get the current time. Okay, okay guys, so tool means function. We need to create function for internet search, calculate the math, read the file, and get the current time. Okay, in simple way, chain is a fixed workflow. Tools means action and function, and agent means decision makers. Okay, so here I'm going to explain simple chain. Okay guys, if you don't use requirement.txt file to install everything, okay, I already install everything by using this, so you can use this. You can uncomment this, or you can install this: pip install -u langchain langchain underscore core, langchain hyphen core, not underscore, okay, langchain hyphen groq python.env. Okay guys, so these are the library we are going to use here. Okay, so langchain means main langchain library. Okay, here also you can see I use these langchains. Okay, so I'm going to explain everything one by one. Okay, so here you can see I import OS. It is used to load this one or this one. Okay, it is used to load the environment variable from .env file. Okay, and langchain means main langchain library. Langchain core means core component like prompt. Okay, langchain groq. Connect langchain with the groq model. That's why I use langchain groq, this one. Python.env. Load the API key from .env file, from this file. Okay. Okay, so this is used for load the env file. Okay, and this one prompt template helps to create the dynamic prompt. Okay, and chat groq prompt template help to create a dynamic prompt. Okay, and chat groq let us use groq here. Okay, groq LLM model. So with the help of this we can use groq LLM model free. Okay, because it is available free. And here you can see I'm going to load the env with the help of this one. Load variable from the .env file, and here read the API keys groq underscore API underscore key os dot get env and groq API key. Guys, this is the variable name. Okay, no, inside this I have actually in .env file I have this variable. Okay, you can put this groq API key inside this env file. Okay, if you don't know how to create env file, sorry, how to create API key, so you can go here, search groq API key, and you need to go here and create your own API key by clicking here. Okay, and put here some name like chatbot, AI agent, whatever you want to build. Okay, and click on create, and then put it into a .env files. Okay, like this I have this file, so I can use, for example, I'm just giving example guys. Okay, you can create your own groq API key, groq API underscore key, and here mention your API key. Okay, okay, but I have my API key in this file .env. This is for example. Okay, and this is for read the API keys. Groq API key equals to os dot get env groq API key. Okay, now initialize the groq language model. I'm going to close this one. Okay guys, so you can see here I'm just going to remove these things. Okay, so here initialize the Groq model. I created one variable here LLM, and here I wrote here chat Groq. Okay, so here we are just initializing the Groq language model. Okay, LLM equals to chat Groq, and here I mention Groq API key, this one. Okay, that it will access the Groq API key and give you the answer. And here I use the model name. Okay, llama 3.1 8v instant, and temperature equals to 0 means more accurate and less random. Okay, and here after this we need to write one prompt means we need to give some instruction to our model. Okay, prompt equals to prompt template. Okay, create a prompt template. Here I'm going to create a prompt template here with the help of this prompt equals to prompt template. Okay, so text is a particular, this one text is a particular placeholder for the dynamic input. Okay, that we can give the input here. So prompt equals to prompt template from template. I import this. Okay, prompt template from LangChain. Okay, and translate the following text to the French. Okay, I provide here text means text is a placeholder for dynamic input because I put here curly braces. Okay, now we are going to create the chain here. Chain equals to prompt, I pass this prompt. Okay, and in the chain equals to prompt, and I pass this LLM. Okay, so we are going to connect steps in a sequence. Okay, so here we are going to create a simple chain. Okay, prompt output, here you can see prompt output. This prompt output goes into the LLM. Prompt output goes into the LLM and create one chain here. Okay, and run the chain with the input text. Result equals to chain dot invoke. Okay, result equals to chain dot invoke, and I'm going to run here our chain. Okay, and here text equals to hello, so it is going to convert this text, okay, into the French. I mention here translate the following text to the French. Okay, and here in output it is going to print the result. So you can see here. Okay, so yeah, I got this output. Okay, now hello converted into a French, that is bonjour. Okay, so this is our first chain. I already explained these kind of things in my previous video of LangChain. Okay, if you don't know LangChain, first understand the LangChain. Okay, then you can come here. Now we can see here agent can use tool dynamically. Okay, agent can use tools dynamically. Okay, so here I'm going to create one function, def simple agent. So here I'm going to use one function, def simple agent. Okay, so this is a simple example of AI agent. Okay, simple agent, inside this I pass the query. Now I'm going to write if. Now convert user query to the lowercase. So matching become the easier. I'm going to convert user query into a lowercase. Okay, if time in array, if time in query dot lower. Okay, if time in query dot lower. So here we are going to convert user query to the lowercase. Okay, so matching become easier. Time in query dot lower, convert user query to the lowercase, so matching become easier. Okay, so import date time module here. Okay, so I use here return return current time. Okay, so I mean return here current date and time. Current time tool plus str. Here I need to pass import underscore date time dot date time now. Guys, so here I'm going to import just current time, okay, plus str import date time and date time now. Okay, so here it is going to return current date time. Okay, and here I'm going to use condition else, and if query is not related to the time. Okay, if query is not related to the time, return a normal AI response. Okay, so here I'm going to return llm llm response llm response I don't know. Okay, now print. I'm going to use this function. I'm going to call this function. Inside this I need to pass what time is it. Sorry, what is the current time. Okay, and now I'm going to ask normal question also. Print simple agent. Here I need to pass hello. So you can see here it is just replying only the time query. Okay, so this is a very simple AI agent, guys. This is a very simple AI agent. The agent first check the user question. Okay, so I ask user ask the question. This one I call this function here. What is the current time? Okay, so this is giving the current time. The time tool. This is going to call but not giving the answer. Okay, so this is a very simple AI tool. The agent first check the user query. Okay, if the question contain the word time, it use a tool to get the current time. Okay, and otherwise it will return a normal response, that is I don't know. This one, okay, that is I don't know. So here tool equals to date time function, and the agent equals to decision maker, and the condition equals to checking the user. Okay, actually I forgot one thing here, that's why it is not giving the answer properly. Okay, now it is giving answer to us. Okay, so I forgot this str import date time and date time now. Okay, so here you can see if user ask the question related to the time, it is going to call this function. Okay, and give the answer by using this condition. Okay, current time is this, and if we can, like, we have another question also. Okay, if this question is not related to the time, then it will generate the answer like this LM response I don't know. You can see here I got I don't know here. Okay, so you can see here now we are going to move here in LangGraph. So LangGraph is a library used to build a smart AI workflow using large language model. Okay, you can see here I also mentioned the definition. Okay, you can think of LangGraph like a flow chart for AI application. Instead of running only one fixed sequence, LangGraph allow the AI application to make the decision. Okay, so they can make decisions, they can use the memory, they can call the tools, which they can decide which tool they need to call. Okay, and retries the step and work with the multiple agents also. Okay, so this makes it useful for building the advanced AI systems. Okay, so key features of this we are going to use in LangGraph. First one is stateful workflow. Okay, so stateful means LangGraph can remember the information between the steps. Okay, stateful means LangGraph can remember the information between the steps. Example, a chat would remember the previous message. This memory is called the state. Okay, so here LangGraph can remember the information between the steps. Okay, and branching logic. Second step is branching logic. LangGraph can make decisions. For example, if user ask about the weather, it use weather tool. Else it use the LLM response. Okay, so the workflow can change dynamically. यहाँ पर क्या करेगा हमारा एजेंट खुद से डिसाइड करेगा कि यूजर ने किस टाइप का क्वेश्चन पूछा है. वो जैसे कि वेदर का क्वेश्चन है, व्हाट इज द वेदर इन बेंगलोर, then it is going to call only the weather tool. Tools means function. जो हमने function बनाया होगा weather से related वो उसी को call करेगा. If you are going to ask the question related to the something else like mathematics, okay, then it is going to call only mathematics tools. Okay, mathematics tools means mathematic function. Okay, so the workflow can change dynamically. Okay, multi-actor system. Multi-actor means multiple agent or component can work together. Example, one agent does research, another agent summarize the result, another agent check the quality. Okay, so multi-actor agents means agent do things, different things. Okay, I mean multiple agent can do different things. Okay, one agent for research, another agent for summarization, another agent for check the quality. Okay, and fourth is persistence. LangGraph can save and load the states. This means conversation can continue later. Workflow can resume after stopping. So use cases of LangGraph for AI chatbot, research agent, customer support bot, decision making system, and AI assistant. Okay, so these are the use cases. Why LangGraph? Simple chains are good for basic tasks. Simple chain are good for basic tasks, but real AI applications are more complex. Sometimes AI need memory, decision making, retries, multiple steps, and human approval. Sometimes AI need these kind of things: memory, decision making, retries, multiple steps, and human approval. Okay. So simple chain are good for basic tasks, but real application are more complex. Sometime we need, sometime AI need memory, decision making, retries, multiple step, and human approval. So LangGraph helps manage these complete complex workflow. Okay, LangGraph help manage these complex workflow easily. Why developer use LangGraph? For better memory management, flexible workflow, error handling and retries, and multi-agent system, and human in the loop support. Means इंसान भी इंटरप्ट कर सकता है. ओके, मल्टी एजेंट सिस्टम, मल्टीपल एजेंट, एरर हैंडलिंग मी एंड रिट्राइज. अगर कहीं एरर आ गया और कुछ गलत हो गया तो एजेंट दोबारा उसका आंसर जनरेट करेगा. ओके, and flexible workflow and better memory management. That's it. And graph versus simple chain. Simple chain means a a simple chain follow one fixed path like this: A connected with B and B connected with C. Okay, like steps connect in sequence. Okay, everything happens step by step. There are no decision, no looping, no branching. Good for simple work. This is called the chain. And in graph, a graph is more flexible. It use nodes. Nodes mean steps and functions. Okay, it use edges. Edges means connections between the steps. Okay, inside this graph we have nodes, edges and state. Edges means connection between the steps, and state means share the memory between the steps. Okay, a graph can make decision, branch into different path. Okay, it it make decision or branch into different path. Okay, repeat step using the loops, store the memory and run multiple components. For example, you can see here we have A connected with B, connected with D, with C. Okay, like this: A connected with C, C connected with D, A connected with B, okay, and D connected with B. So this makes graph powerful for advanced AI workflow. ओके, सो यहाँ पर क्या हो रहा है, ग्राफ खुद डिसीजन कर रहा है. ठीक है, ब्रांचेस के ब्रांच इनटू डिफरेंट पाथ and repeats step using loops. So in graph we can do these things, guys. Okay, so you can see here we have this workflow. Okay, we have this workflow. Let's understand this workflow step by step. Okay, start. This is where the AI workflow begin. Okay, process input. You can see here process input. The application first read and process the user input here. Okay, here this is the step. Okay, this is the step where the AI workflow began. Okay, and here process input means the application first read and process the user input. Application first read and process the user input here. Decision action. Okay, 1 minute. Start, this is first step, and process input. The application first read and process the user input here. Okay, for example, user ask what is the weather today. Here in input process input, user ask what is the weather today. Okay, decision action. So now the system decide what to do next. Okay, for example, it should use an LLM here. And should it call the weather tool, or does it need more information? So here agent going to take the decision. Okay, and this is called the decision making here. This is called the decision making here. Okay, and now you can see tool or LLM. Tool or LLM means based on the decision, it may call the tools or send the request to the AI model here. Okay, so it use an LLM, or should it use an LLM here, or should it call a weather tool? Does it need more information? Okay, so this is called the decision making. Okay, this is called the decision making. So tool or LLM, so based on the decision, it call tools or send the request to the LLM model. Okay, so if the question related to the weather, so it call the weather API. Okay, weather API tool, and generate the generate the response. Okay, so here it generate the response here, and you can see here update the memory. After generating the response, the system save the useful information into the memory. For example, user question, previous response and conversation history. This helps the AI to remember the context. Okay, so here last step, and finally the workflow finish and retries. Here finally the workflow finish and return the response to the user here. Okay, so you can see here, यहाँ से स्टार्ट होगा, यूजर का इनपुट आएगा, प्रोसेस होगा. फॉर एग्जांपल यूजर पूछेगा प्लीज जनरेट द जोक. ओके, तो यहाँ पर एजेंट्स रहेंगे, वो डिसाइड करेंगे कि हमें टूल यूज करना चाहिए कि डायरेक्ट LLM यूज करना चाहिए, और क्या हमें मोर इन्फॉर्मेशन की ज़रूरत है. अगर हमारे पास कोई टूल है जो जोक जनरेट कर रहा है, तो इट विल कॉल द टूल. ओके, सो एजेंट ऑटोमेटिकली डिसाइड करेगा कि उसको टूल के पास जाना है, LLM के पास जाना है, ठीक है। तो यहाँ पर वो रिस्पॉन्स मतलब जनरेट करेगा और अपनी मेमोरी को अपडेट करेगा कि यूजर ने क्या पूछा था और मैंने क्या आंसर दिया, और एंड में यहाँ पर खत्म हो जाएगा, ठीक है। इफ रिस्पॉन्स इज अनक्लियर द वर्क फ्लो कैन लुक बैक एंड ट्राई अगेन. Okay, this is something normal chain cannot do easily. Okay guys, so this is called the workflow of LangGraph. So installation and setup, install the required package and setup API keys. I already install here in requirement.txt. Maybe I have LangChain, LangGraph. Okay, so I don't need to install, otherwise you can install like this also. Okay, you can uncomment and just hit the enter, shift enter button. Okay, then it will install everything. There is no need to install everything, Streamlit as of now. Okay, and here print the package installation run. So here it will print the package. Okay, package install or not. Okay, and here you can see we can set up the API keys like this, import the OS. We can use Groq API here, so set the Groq API key environment. Okay, I already put API keys in env files here. Okay, so here you need to put here API keys. Okay, so quick test basic LangGraph imports. Okay, so here I use try from LangGraph import state graph. State means we are going to flow the information from one step to other. Okay, so here you can see print the LangGraph import successfully, accept import the error, print the install LangGraph first. Okay, तो यहाँ पर हम चेक कर रहे हैं कि LangGraph import successfully हुआ है नहीं हुआ, otherwise it will give you the error if it is not installed here. Okay, so install LangGraph first. So you can see here in summary guys, LangChain, chains and agent for LLMs. Okay, if somebody asks you question like what is the difference between LangChain and LangGraph, you can say in LangGraph we learn chains, agents, we work on chains and agents for LLMs, and in LangGraph stateful graphs for context workflow. Okay, now we are going to move. So here now we are going to move in another file. So here I have completed this one, basics of LangGraph and LangChain. Okay, now I have finished this. I hope you got everything. Now we are going to move here core concept of LangGraph. Now we are going to move here in file number 202 core concept of LangGraph. Okay guys, I hope you have an idea about LangGraph. Okay, if you don't have idea about this, no worries. Okay, so first we have nodes in graph. Okay, so nodes are the building block of graph. Okay, you can think of a node as a steps, task, or a function. Okay guys, so this is like a function. Nodes mean simple Python function, nothing else. Okay, each node performs some work inside the workflow. For example, taking user input. Okay, each node performs some work inside the workflow. For example, taking the user input, calling an AI models, using a tool and saving the memory and making the decision. That's it. In simple word, one node equals to one job. Okay, so here I'm going to write one node. Okay, so here I'm going to create one function. This function is a simple node. Okay, so here I'm going to create one node. Okay, this is called the process underscore import state. Here I pass the state. Okay, so this function is a simple node in LangGraph style workflow. Okay, and here I'm going to write first line. Okay, state. Here state, state input equals to state input dot upper, not lower, it should be upper. Okay, state input equals to state input dot strip dot upper. So here it should be processed. 1 minute, processed. Okay, state processed equals to state input dot upper. Okay, so this is our final line, and return the state. Okay, so here you can see this function is a simple node in LangGraph. Okay, and here you can see take user input from the state dictionary. It is going to take the user input. Okay, it is going to take the user input from the state dictionary. Okay, state processed equals to state input means user input. Okay, and convert it into a uppercase. ओके सो यहाँ पर क्या हो रहा है, इट टेक यूजर इनपुट फ्रॉम द स्टेट डिक्शनरी. ओके सो यहाँ स्टेट प्रोसेस इक्वल्स टू, दिस इज अ वेरिएबल, स्टेट प्रोसेस इक्वल्स टू स्टेट इनपुट्स. हियर it is going to take the user input and convert it into a uppercase. Okay, and return the updated state, so next node can use it. Okay, and after this state equals to input. In input I need to pass hello. Okay, here I need to pass hello, and so this is the example of state. Okay, this is like a shared memory. Input equals to hello and processed array process is equals to empty string. Okay, so this is the example state. This is the example state. This is like a shared memory. Okay, I have comma, one comma, hello, input, and then processed. Break it, close, break it here. Now, it should be comma here. Okay. Now I'm going to call the function node. Okay, so here I'm going to call function node. So new state equals to process input. I use this function process input. Here I pass the state. Okay, and here print the updated state. So here I'm going to print the updated state. Okay guys, so this is the simple Python function. This is the state processed. Okay, here it is going to take the user input and convert it into uppercase. Okay, and this is like a example state. This is like a shared memory. Okay, shared memory means memory. It is going to share this kind of memory that input is equals to hello and process equals to as of a empty string. Okay, and new state, this is also a variable. Okay, new state equals to, I use this variable, sorry, this function name. Here I pass this state as a memory, shared memory, and print the new state. So I got this one, input equals to hello and process equals to also hello. तो यहाँ पर क्या हुआ, we just create one function process input. ओके तो हमने स्टेट मीन शेयर, यहाँ स्टेट में हमें यहाँ पर क्या दिया था, दिस इज लाइक अ शेयर्ड मेमोरी. ओके, हेलो एंड प्रोसेस इक्वल्स टू एमपीटी. देन हमने यहाँ पर एक वन वेरिएबल बनाया, जिस ए फंक्शन को कॉल कराया है. मैंने यहाँ पर स्टेट पास किया, मतलब ये सब ठीक है. फिर यहाँ पर उसने प्रिंट किया. सो इन नाउ न्यू state I got this hello because it convert here, user input converted here into uppercase. Okay guys, so this is the simple function. Now you can see here ages. What is ages? Oh, 1 minute. So 1 minute, I'm going to explain this function again. So this function take a state. Okay, this function take a state as an input, state or a dictionary. Okay, so this function take a state as an input. It read the upper input from the state. It read upper input from the state and process it, convert to the uppercase. Okay, and process it and store here. store the result back into the same state. Okay, and finally it return the updated state here. Okay, so basically input, so here basically what we have, I mean here I need to mention, so basically input process and update the state, and here I got the output. ठीक है. Now you can see edges define the flow between the nodes. Okay, so type of edges क्या होती, क्या क्या होता है. Normal edges always always follow normal edges, and conditional edges when we use based on condition. Okay, they can be unconditional or conditional. Okay, so I will tell you about the edges more after some time. Okay, and state means share memory across the graph. State means share memory across the graph. And best practice, you can see here, use dictionary, keep it serialized, and update the immutability. It's a dictionary that persists between the nodes. स्टेट क्या है, जस्ट सिंपल हम मेमोरी शेयर करते हैं ग्राफ में, नथिंग एल्स. हम यहाँ पर भी ये यूज कर रहे थे स्टेट. Okay, so I'm taking one example of a state in LangGraph. Okay, so a state is basically a shared memory that store data across the steps. Okay, so I'm going to create initial state, initial state. So here I need to remove this one. Initial state, here I pass message. Okay, comma. So message means list to store the message or log of each step. Message means list to store the message or log of each step. Okay, and here we have memory. Memory. Okay, so here as of now it is empty. Okay, so this is the dictionary to store the important information like catch or context. Okay, so this is used to store the important information in memory. So as of now it is empty, and here you can see counter equals to 0. Okay, so here it's me keep track what? Keep track of how many steps have happened. Okay, dictionary, this is the dictionary to store the important information, and this is the message list to store the conversation history, or we can say message. Okay, so this is like initial state. Inside this we have message, memory, and counter. And here I'm going to define one function, update. So here this is the function update. Okay, so you can see here this one update. Everything is wrong here. Update, inside this I need to pass counter. Update state Here I need to pass counter. Okay, so here with the help of this line, increase the counter by 1 each time when function run. Okay, so I mention here in comment, yeah, increase the step counters. Okay, increase the counter 1 by 1 each time when function run. Okay, and here state message dot append, state message dot append. Here I need to change. F step state counter. Okay, so you can see here, add a new message showing the current step number. Add a new message showing current step number. So state message dot append f of steps. Here state, inside this we have counter. Okay, now it is correct. Mm-mm. 1 minute. It is, I used to curly bracket here. Okay, now it is perfectly fine. Okay, add a new message showing current step number. So here I'm going to add a new message. Okay, state message dot append. Here inside this I'm going to append the new message, state step counter. Here state message dot append step state counter. Add a new message showing the current step number. ओके तो हम आई मीन मैसेज ऐड कर रहे हैं, न्यू मैसेज. ओके, एंड इट इज शोइंग द स्टेप्स ऑफ करंट नंबर. ठीक है, and after this we are going to return the state. Return the state. Okay, so dot copy is used so original state is not modified directly. Okay, so we are passing a copy of initial state into the function. So here I'm going to mention print updated state initial state dot copy. Okay guys, let me check why I got error here. Print updated state initial state, this one dot copy. So copy is used so original state is not modified directly, so that's why we use copy, and we are passing a copy of initial state into the function. So let me check why I got this error. Where is the mistake? Updated state missing one argument, positional argument, user input. 1 minute. Here we have initial state, message, memory, counter, updated state. I pass here user input. There is no need of user input, guys. Okay, so now it is perfectly fine. Okay, so we have initial state, memory, counter, and message. This is updated state. Okay, and we are going to use counter here for increment of step, and here we are going to add new message and return the state and print the updated state. This one, initial state dot copy. So here it is use copy. So original state is not modified directly. We are passing a copy of initial state into the function here. Okay, so step message equals to step 1. Okay, and memory is empty as of now. Okay, and counter is equals to 1. So this code, this code show how the state work in LangGraph. State is like a notebook that keeps updating itself. Every time the function run, counter increase. This counter, okay. If every time function run, this function counter increase, okay. Counter increase by 1. A new step message is added. काउंटर इंक्रीज हो रहा है और न्यू मैसेज ऐड हो रहा है हर बार. सो द सिस्टम रिमेंबर व्हाट हैपनिंग इन द प्रीवियस स्टेप. सो दैट्स व्हाई वी कॉल इट्स स्टेटफुल वर्कफ्लो. ठीक है, यहाँ पर क्या हो रहा है, काउंटर इंक्रीज हो रहा है, मैसेज ऐड हो रहा है, फिर अगेन काउंटर इंक्रीज हो रहा है, मैसेज ऐड हो रहा है. सो द सिस्टम रिमेंबर व्हाट हैपन इन द प्रीवियस स्टेप. सो दैट्स व्हाई इट्स कॉल्ड द स्टेटफुल वर्कफ्लो. ओके, now you can see here we are going to move here in conditional routing. Routed based on the condition like if else flow. ठीक है, तो इसमें कंडीशनल राउटिंग में क्या होता है कि जो मैच करेगा उस कंडीशन में हम लोग जाएंगे. ओके, सो राउट्स बेस्ड ऑन द कंडीशन लाइक इफ एल्स फ्लो. ओके, इफ क्वेरी कंटेंट हेल्प्स लाइक FAQ notes. ओके, if confident is less than 0.5 means human review. Okay, so this function here I'm going to create one function. Okay, like this. Okay, so this function def decide route, this function decide whether the flow should go next in a graph. Okay, so here I pass the state I already said the memory flow of memory. Okay, so here it is basically a routing function like traffic control for AI. Okay, if tool in state input dot lower. So here you can see convert input to a lowercase, so matching in case sensitive. Convert input into a lowercase here. Okay, if tool in lower input, here I'm going to convert input into a lowercase. Okay, check if user asking about the tool. Okay, here then it will return the tool node. Okay, and here you can see else condition, elif condition. Check if user need a help or support. Okay, elif help. Okay, अगर यूजर को इनपुट में कोई हेल्प नाम की चीज दिख रही है कि उसने हेल्प मांगी तो क्या रिटर्न करेगा, फ्रीक्वेंसी आस्क नोड. ओके ओके, otherwise it will return the LLM node. Okay, if nothing match then default it will return LLM response. Okay, we can test it with the help of print. I'm going to call this function decide route, similar here and I pass input I need help. Okay, so it will call this one. It is not related to the help. This one is going to call this. Okay, and you can see here I'm just going to print first one input I need a help, I need a tool, not help. So it is going to call this one tool node. Okay, here help me, it is going to call this tool, this condition. Okay, this tool. Okay, this node. Or here else LLM node, I ask just hello, input equals to hello, then it is going to call this. ओके गाइस, तो यहाँ पर बस कंडीशन है, कंडीशन के मैच पे अगर आपने जस्ट टूल यूज किया तो इसने ये वाला यूज कर लिया, और आपने हेल्प के लिए यूज किया, हेल्प के लिए बोला तो उसने ये यूज कर लिया, और आपने दोनों में से कुछ भी नहीं पूछा ऊपर वालों मैं जो दो कंडीशन है तो ये ऑटोमेटिक आपको LLM नोट दे देगा. दैट्स इट. So this is called the routing. Okay, this is called the routing. So this function is like a traffic police for your AI system. It check user input and decide whether request should go. Okay, if user content tool, here user content the tool, it go to the tool node here. Okay, and if it is content help, it go to the FAQ node, this one. Okay, and here otherwise go to the LLM node. Okay, so that's it guys, nothing else. So instead of one fixed path, the system can now make the decision. This is called the conditional routing. Okay, now we have loop, allow retrieve or iterative process. Use cases retry on failure, refine the answer, multiple step reasoning. Okay, so यहाँ पर हम we are going to build some simple demo for it. Okay, for questioning answering agent with memory. So basic agent that answer the question and remember the context. Okay, so you can see here I import the API keys from our .env files. .env file. Okay, with the help of this I got my API key. This is the variable os.get env Groq API key. Here I can check API key, it is true. Okay, now I'm going to write code here. Actually I already have code, so I'm going to copy from here and I want to paste it here. So here you can see this code show a very simple LangGraph step with only one node. Okay, so if you need you can install the other things. I already install. Okay, so no problem. So here you can see from LangGraph I'm going to import a state graph. Okay, it will show you flow of the memory, okay, inside the graph. And from LangChain underscore Groq I'm going to import chat Groq, that we can use Groq model here. Okay, this is the Groq model. Okay, so initialize the Groq here, Groq LLM models. Okay, so this is the AI model that will generate the response. LLM equals to chat Groq. Okay, Groq API equals to Groq API. API key for authentication. Model name this one. Okay, model used, and temperature equals to 0. 0 means more stable and predictable answer. Okay, and after this we have nodes. So guys, I'm going to copy from nodes, means just a function, nothing else. Nodes means function, nothing else. Okay, so this is the node dfllm underscore node, and here I pass the state. So this is the node function of the graph. Okay, and you can see here user underscore message. Here I pass the state, message and last message. So it means get the last user message from the state. ठीक है, get the last user message from the state. Okay, okay, flow of memory, flow of the information with the help of state we can do. Okay, and here get the response from the Groq. Response equals to llm dot invoke, I pass here user message. Okay, so get the last message from the user with the help of this, and this one send the message to the LLM and get the response. Okay, and save the response here. Save the response here. So here you can see state message dot append response dot content. So store AI response back into the message list. Okay, so here we are going to add or store AI response here, AI response. Okay, so in message I'm going to add response content, means store AI response back to the message list. Okay, and here save the last question, state memory last query. Okay, so here save the last question in the memory from for tracking. Okay, here I pass user message and return the state, updated state. And after this I have another lines, this is for graph. Okay, I'm just going to create graph. So here you can see graph, create a graph. Graph equals to, I use state graph. Okay, state graph I already saw you. State means we have flow of memory or information. Okay, graph equals to state graph, I pass here dictionary. Create a LangGraph object using the dictionary as a state type. Okay guys, this is the kind of object of LangGraph. Okay, this is called the LangGraph object using the dictionary. Okay, you can see graph equals to state graph, and here I pass the dictionary. Yes, I want that. Okay, and here we are going to add node. Okay, llm underscore node, this one I use this node and add here, add a node, graph dot add node. ये भी हमारा इनबिल्ड है. Graph dot add node, I pass here llm. Okay, llm means model, and here I pass this llm nodes, this llm. Okay, this llm and llm node, and after this add the llm node to the graph, and after this set starting point of the graph. Okay, so graph dot start, set the entry point llm. Okay, this is called the starting point of the graph. Graph dot set underscore finish point llm, so this is the ending point. Okay, this one is ending point. Graph stop after this node. Okay, graph stop after this node. And this one set the starting point of graph. Okay, no, this is this is the not, this is not a starting point, this one is a starting point, this one. Okay, and this one is entry point. Entry we can say add llm node to graph. Okay, so guys, these are the, this is the node, this one. Okay, and this is the entry point, and this is the finish point, means end point of the graph, llm, sorry, graph. So now we are going to compile this. So we have other step to compile this graph. I'm going to copy from here to here. So compile graph. So here I use app variable, app equals to graph. So this is the graph. Where is it? This one, graph dot compile. Okay, so here we are going to compile graph into a runnable app. Okay, compile graph into a runnable app. And you can see here initial state. Initial state I pass memory, message equals to what is AI. Okay, so this is the user question. And memory equals to store for extra information. This is for extra information. This is the empty as of now. Okay, so this is the initial state. Okay, like input plus empty memory. This one is input, and this is a empty memory. And here you can see run the graph, result equals to app dot invoke, means run the graph. Here I pass this initial state and print the result. So you can see here what is the output. I'm waiting for it. So you can see what is an AI. So this is the user query and this is giving answer. Artificial intelligence refer to the simulation of human intelligence in machine that are okay guys. So this is the definition. Okay, so this is the answer giving by the graph. You can copy and paste it here and check what we have inside this. Okay guys, so this is the answer, that much. Or you can say here in memory, this one, it is showing last query. And what is AI? इसने मेमोरी में स्टोर कर लिया कि लास्ट क्वेरी क्या थी, और एआई इसने लास्ट क्वेरी में क्या पूछा था, व्हाट इज एआई. ठीक है, तो इसने मेमोरी में रख लिया. एंड दिस इज द query, user query. In message we have user query. So guys, this is the message and this is the memory. This one is memory and this is the answer in middle. Okay guys, so here this is the simplest LangGraph example. Okay, we just use one node. One node means this one LLM node. Okay, and one graph. This is our one graph. Okay, and one execution flow, this one. So here step by step by flow, we take the user input. This one is user input from the state, what is AI. We send it to the LLM, Groq LLM, Groq model here. Okay, we get the AI response and we store the response back into the state here and graph end. Okay, and so flow is input, LLM and output. So here LangGraph is just managing the flow and state. Okay, so right now this graph is simplest, but LangGraph become more powerful when we add multiple nodes and decisions and loops. Okay, this is a simple example guys. Now we move here, building your own simple graph. Okay, so here I'm going to build our own simple graph. Here I'm going to create with 3 nodes: input, processor, decision maker and responder. Okay, so here I'm going to create a simple LangGraph example that show input, processing and decisions here like this. I'm going to mention here input, and then we process this input, processing of this input, and then take the decisions. Okay, and then differentiate the output. And then end. Okay, so here from I'm going to import, I'm going to create a 3 graph. Okay, so you can see here exercise, build a simple graph. Okay, first we are going to define the state and then create the node and then add the edges and compile and run. Okay, so here I just import from LangGraph.graph, import the state graph and end. Okay, so this is like I'm going to import this state graph. State means flow of the information in the graph and end means last point. Okay, end point of the graph. Okay, so here these are the nodes. Okay, I just create nodes means simple function. Okay, so this is the first function, input process. Okay, we are going to process our input here. Okay, I pass here state means flow of the memory in the graph. Okay, state process, this is the variable name, state process. Here state process equals to state input in lowercase. Okay, and then return the state. So here you can see, take the user input in this line, take the user input and remove the extra space and convert into a lowercase and return the updated state here. Okay, and then you can see here we have another node that is decision maker. Another node means decision maker. here I pass the state. Okay, so this node doesn't change the state. This node doesn't change the state. Okay, so here decision maker, this node doesn't change the state, it only exists to trigger routing decision. ओके, ये डिसीजन लेगा कि कौन सा नोड मैं यूज करूँ कौन सा ना करूँ, दैट्स इट. ओके, नाउ वी हैव अनदर नोड. ओके, route underscore decision, here I pass the state. Here if length of state, so you can see here it, I mean this one routing function, this is very important. Okay, check the length of process input, it is going to check the, you can see here, check the length of process input. If length of process input is greater than 10, then it return the long, otherwise it will return the short. I means go to the short answer, short node answer. Okay, go to the short answer node. If it is like long, if input is long, then it use first condition, this one. Okay, go to the long answer node. So it is going to take the decision. If length of input is greater than 10, then go to the long answer, otherwise go for the short answer node. Okay, then we have another node, long responder. So this one is for long response node. Okay, so here you can see I pass this state response here. Okay, this one is variable name state response. Okay, equals to long answer for, okay, and plus state process. So this means create the, so I mean create the detailed response. Okay, I also pass the state process here and return the state. Okay, state process response, this is the variable name state response. Here long answer for state processed. Okay, and then this is for short response. Okay, so short responder state, here create the short response. Short response equals to short, here is it is used state response, state processed. ओके, रिटर्न दी स्टेट. सो गाइस यहाँ पर ये शॉर्ट आंसर दे रहा है, यहाँ पर ये लॉन्ग आंसर के लिए नोड बना है, यहाँ पर डिसीजन ले रहा है कि मुझे कौन सा यूज करना चाहिए, शॉर्ट नोड, शॉर्ट आंसर, सॉरी शॉर्ट लॉन्ग रिस्पॉन्डर और शॉर्ट रिस्पॉन्डर फॉर आंसर. ठीक है, यहाँ पर डिसीजन मेकर है और यहाँ पर इनपुट प्रोसेस्ड है. दिस वन आई यूज दिस वन एवरीवेयर, स्टेट इनपुट प्रोसेस, जो यूजर की इनपुट है वो हम यहाँ पर ले रहे हैं, यहाँ पर वो चेक कर रहा है इफ यूजर इनपुट इज ग्रेटर देन वी यूज लॉन्ग, ग्रेटर देन दिस. ओके, एंड देन अदरवाइज इट विल सॉर्ट. ओके, यहाँ पर भी हमने यहाँ पर क्या लिया, स्टेट प्रोसेस, जो यूजर का इनपुट है उसको यहाँ पर लॉन्ग शो कराना है, और यहाँ पर भी जो यूजर का इनपुट है, यूजर इनपुट. ओके, यहाँ पर हम शॉर्ट आंसर देना, रिटर्न दी स्टेट, दैट्स इट. ओके, so here after this I'm going to create graph. Okay, so maybe I have code for graph. So you can see I have created one variable graph equals to state graph. Here I pass the dictionary. ये variable नहीं है guys. We can initialize graph like this. Okay. So here this is the graph object. Okay, graph equals to state graph. Here I pass the dictionary. Okay. And now this is like here I'm building the graph. This one. Okay. Now we have a nodes graph dot add nodes. Okay, here I pass input node, here I pass the input process. This one input process means this is our input, this is the our first node input process. यहाँ पर हम input pass कर रहे हैं, we just pass the input here. Okay, and graph dot add node we are going to use this one, decision maker, this one. Okay, so here I use decision maker and here I pass the decide, and graph dot add node, here I use long, and this one is the function name I use here. Guys, these are the function name. Okay, means node name, we already use these node here. Okay, graph dot add underscore node sort and sort underscore responder. Okay, and here flow graph dot set underscore entry underscore point, I use input, this one. Okay, so here is set the starting point. In starting point, what we have user input, right? Okay, so that's why I pass this input. In input, what we have this function. इनपुट प्रोसेस, यहाँ पर वो यूजर इनपुट लेगा, ठीक है, एंड रिटर्न करेगा. दैट्स इट. एंड देन इट विल डिसाइड. ओके, यूजर इनपुट लेगा, देन डिसीजन लेगा. ओके, बाय यूजिंग दिस नोड डिसीजन मेकर. And then it will decide like I need to give long answer and I need to give short answer. It use one. Okay, after decision. So here uh, that's it guys. Here connect the input to the decision, this one. Okay, and sorry, this is the entry point, set the entry point. Okay, and here I forget sorry, this one is input and this one decision, long and short. Okay, and here graph dot set entry point, this is the starting point. Okay, and here graph dot ages, this is the age guys. Okay, ages. So here I pass the input and decide decision. So here we are going to connect this input function to the decision. Okay, so connect the input to the decision, तभी तो वो decision लेगा ना, based on the input. Okay, otherwise how can take decision? So conditional routing, you can see here, this is the main brain of the LangGraph. Graph dot add conditional ages. Okay, so here I pass the decide, and inside this I have route underscore decisions. Okay, so first I use in graph dot conditional ages. Okay, here I use decision, this one. Where is the decision function? This one, decision maker. ओके, तो यहाँ पर डिसाइड करेगा कंडीशनल एजेस से राउट डिसीजन. ओके, राउट डिसीजन, दिस वन, डिसीजन मेकर. ओके, एंड देन राउट डिसीजन इफ लॉन्ग, if input is greater than 10 then answer should be long, otherwise it will sort. Okay, so here I pass long and sort. guys, ये दो फंक्शन है ऊपर वाले जो हमने यूज किए हैं. ठीक है, डिसीजन एंड दिस वन, डिसीजन मेकर एंड राउट डिसीजन. ओके, अरे यहाँ पर मैंने पास किया है लॉन्ग and sort. Based on this it will decide that I need to give the answer short or long. That's it. Okay, then after this final load graph. So here I need to copy from here to here. And noded and node. Okay, so final load graph, I mean final nodes graph end here. Okay, so graph dot and add underscore ages, this is for age. Here I am going to end here. Okay, so final load graph end here. So here graph dot add underscore ages long. Okay, if answer is long then it will end here, and graph dot ages if answer is short then also end here. ओके, सो यहाँ पर वो फाइनली नोट्स जो हैं ग्राफ एंड हो रहा है यहाँ पर. ठीक है, ओके, एंड नाउ वी आर गोइंग टू कंपाइल एफ इक्वल्स टू ग्राफ डॉट कंपाइल. ओके, कंपाइल द ग्राफ इनटू अ रनेबल एफ, and here you can see run the graph, result equals to f dot invoke and input equals to, this is the long question, and return the print the result here. ओके गाइस, आई होप यू गॉट इट. हमने यहाँ पर क्या किया, बहुत सारे नोड बनाए. ठीक है, इनपुट नोड, डिसीजन मेकर, राउटर मेकर, जो लॉन्ग रिस्पॉन्स कर रहा, शॉर्ट रिस्पॉन्स कर रहा, उनके ऐड नोड को ऐड किया, कनेक्ट किया. ठीक है, एंट्री पॉइंट डिसाइड किया, ऐड किया इनपुट को डिसीजन से, देन कंडीशनल एजेस लगाएगी, कौन सी कंडीशन ले सकते हैं, लॉन्ग आंसर मिलना चाहिए, शॉर्ट आंसर मिलना चाहिए. फिर उसके बाद ग्राफ को एंड किया, देन कंपाइल किया, देन यहाँ पर रिजल्ट प्रिंट करा दिया. Okay, so what is the input? Input is, this is the long question. Okay, and process, this is the long question, and response is long answer for, this is the long question. So this is the answer, guys. Okay guys, so this is for example, nothing else. You can improve this later. Okay, so here you can see this graph takes the input and decide how to respond. Okay, this one input node take the user input, clean it and remove the space and lowercase. Okay, and this one is decision node, check the input length and decide the route. Okay, decide the route, that routing, this is the routing function. If input is long, go to the long response, and if input is short, go to the short response. Okay, okay, response node, long responder means detail answer, Short responder means short answer. That's it. This one. Okay, and I use and this one, and means graph stop here. Okay, so this is our graph and the flow of this input, process, then decide, then branch, and we got output here. Okay, so this is the summary. Node means function that process state. Age means control flow. Okay, and state means share memory. मैं बहुत बार state use कर रही हूँ, means share memory. Conditional means branching logic, and loop means iterative and process. Guys, this is simple. Okay, so this is the simple graph we can build like this. First we need to create node. Okay, then we add node and create the graph, set the entry point and decide, connect input with the decide. Okay, then use conditional edges and then end the graph and compile the graph and get the result here and print the result. That's it, guys. So hello, now we are going to move here file number 03 intermediate.py. So here we are going to learn what intermediate concept in LangGraph. Okay, so now that we understood the basic of LangGraph, let's move to the intermediate concept. Okay, so in this section we will learn how to build our advanced and real world AI workflow. So these features make LangGraph powerful for production level AI system. Okay, so you can see here in basic example we use normal dictionary for state, but in larger project it becomes difficult to manage the state properly. So we use typedict here. Typedict, with the help of typedict help us to define what data exists in a state and expected data type and better structure and readability. Okay, for example, message we can store in a list, memory can in dictionary we can store in dictionary, and counter should be integer. Okay, so these make state management clear and easier to maintain. You can see here one example. I'm going to import typedict from the typing. Okay, and this is the class. This is the class. 1 minute. And this one is the, define the class structure of state. Okay, here I pass the typedict. Okay, typedict define the data type of data. Here message should be list of string. Okay, and memory should be in dictionary, and counter is equals to integer. We need to have counter in integer. Okay, so state agent, you can see this one is used for state following this structure. Okay, so this is the example state following this structure, example state. Okay, so here state, I pass here state and this agent, and here message should be stored here in empty list, memory in dictionary, and counter should be integer, and print the state. So you just see here, or you can see here, message in list, memory empty, dictionary, and counter should be 0. Okay, okay, so now message here in list, memory in dictionary, and counter integer. This makes state management clear and easier to maintain. Okay, now we are going to move here multi-actor graph. So graph with multiple agent interacting. Okay, a multi-actor graph contain multiple agent or nodes working together. Instead of one AI handling everything, different agent can perform different tasks. Example, one agent does research. You can see here I have this one example. One agent does research, one agent summarize the result, one agent check the quality. This make workflow more modular and scalable. So you can see here agent 1 is goes to here, agent 1 connect with agent 2 and then end. Agent 1 perform the first task, agent 2 perform the next task. This one is perform the first task and agent 2 is perform the next task, and final result ended here. Okay, result written here, final result is written here. Okay guys, so after this, actually I have code. So first I need to define the agents. Okay, I'm going to copy from here. I have code, I don't want to write again. Okay, so guys, I'm going to import from LangGraph dot graph, import the state graph. Okay, and then end. State graph means it can store the memory and flow of memory. Okay, end means and stop the graph somewhere. Okay, so here we can see here nodes. So this is the nodes means function. Okay, agent 1 node. Okay, so this is the function. So here define agent 1, here I pass the state. State means flow of memory. Okay, so agent 1, you can see state message dot append agent 1 response. So here what is doing here, add agent 1 response into the message list. Okay, so here I just need to mention add agent 1 response to the message list. Okay, so you can see here add the agent 1 response. This is the agent 1 response to the message. हम यहाँ पर जो agent 1 है उसके response को message में add कर रहे हैं. Okay, then you can see here save the agent 1 status into the memory. So here what I'm going to do, save agent 1 status to the memory. Save agent 1 status to the memory. Okay, this is the memory guys. State of memory matlab means current memory. Okay, so memory of agent 1. So save the agent 1 status to the memory here. So agent 1 status is going to save here in the memory. Okay, and it is going to complete and return the state. Return the state means updated state. Here return the updated state. Okay, and here this is agent 2 node. Define the agent 2 state. So these are the message, current message, present message, is because we have a state of message. Okay, so add the agent 2 response into the message list. Okay, similar like this. Okay, so this is the agent 2 response I'm going to add into the message list. Okay, and then I'm going to save agent 2 response into the memory, and here it is completed, and return the updated state. Okay, and return the updated state for the agent 2. Now after this I need to build graph. So guys, you can see here this is the graph. Okay, so after agent 1, agent 2, we need to create one graph. So this is the instance of graph. Graph equals to state graph. Here I use dictionary. Okay, so create a graph using dictionary as a shared data. Create a state graph with dictionary as the state type or shared data. As share state. Okay, so here I'm going to add in this graph dot add node. I'm going to add the node here. Okay, agent 1, you can see here this is our agent 1. I'm just adding agent 1 and then I'm just adding agent 2 here. Okay, हमने यहाँ पर दोनों node means function add कर लिया, agent 1 and agent 2. Okay, now I'm going to set the entry point of graph. Okay, कहाँ से शुरू हो रहा है graph? So graph dot set underscore entry point agent 1. Agent 1 it started with agent 1. Okay, and I'm going to add age. Okay, so graph dot add underscore age agent 1 to the agent 2. Here agent 1 is going to connect with the agent 2, and in the end graph dot add age agent 2 and end here. It is going to end on agent 2. तो गाइज यहाँ पे हमने दोनों नोड ऐड किए. ठीक है, हमने एंट्री पॉइंट डाला कि हमारा फर्स्ट स्टार्टिंग पॉइंट एजेंट 1 है और एंड पॉइंट हमारा क्या है, एजेंट 2. हमने यहाँ पर एजेंट 1 को एजेंट 2 से कनेक्ट किया. दैट्स इट, नथिंग एल्स. नाउ वी आर गोइंग टू कंपाइल. Okay, now we are going to compile the graph. So I'm going to copy from here to here. So you can see here app equals to graph dot compile. With the help of this we can run a graph. Okay, so result equals to app dot invoke message, memory and counter and print the result. So here I'm going to print. So you can see here in message I got response 1 and agent 1 response, agent 2 response. Okay, and in memory you can see here, where is memory, agent 1 completed, agent 2 completed, like this. This one is for agent 1 completed, agent 2 completed, agent 1 completed, agent 2 completed, counter 0. Okay guys, so this is our code. So here we have two agents, agent 1, this is our agent 1, and agent 2, this is our agent 2. Okay, and flow of this, agent 1 is going to connect with agent 2 and then end. Okay, so both agent update the message and store the information in shared memory. The important thing is both agent work on the same shared state. Okay, so this is how multiple AI component can collaborate inside the one workflow. Okay, now we are going to learn error handling. Okay, error handling in real applications. Error can happen anytime. Example, API failures, invalid import, tool error. So we use try except block to safely handle the error. Instead of crashing the workflow, we can catch the error, save the error message and retry the states and continue the execution. Okay guys, so here I'm going to write code for this. Okay, so this is the function. Okay, risk underscore node means this node demonstrate how to handle the error safely in the LangGraph. Here I pass the state for memory and I use try and exception. Okay, so here you can see try block. Try block is used to run the code that may cause the error. Okay, so here you can see simulate the error. If state you can see here if counter is greater than 5. Okay, so here simulate an error condition if counter become greater than 5. Here counter become greater than 5. Okay, so manually raise the error, raise the value error, counter is too high guys. Okay, and state increase by the counter increase by the 1. If no error happen, counter increase values. Okay, and here you can see success information into the save the success information into the memory. So state memory status success. So here save the success information into the memory. Okay, and return the updated state. Okay, and this is our first condition. Try block is used to run the code that may cause the error. Okay, if counter is greater than 5, then it will raise the error that counter too high. Okay, otherwise it will increase the counter and save the status into the memory that it is successful and return the update stage. state, sorry. Okay, and in exception as you can see here, except block run if any error occur. Okay, except exception as e. Okay, so you can see here, save the error message into the message list. Okay, so this is our message list. Inside this message list, okay, inside this message list, it is going to save the error. It is going to save the error message into the message list. Okay, append error, here error is going to save here. Okay, save the error message into the message list. Okay, and store error detail in the memory. Store error in memory. So state memory last error. So we are going to store these error inside the memory. Okay, equals to STRE and return the updated state with the error info here. Now we are going to test this. Okay, so here inside the test, I pass state equals to message memory, memory in dictionary, message in list, and counter equals to 6. Okay, this will trigger the error, counter equals to 6. Okay, result equals to, I use this node, risky node, and here I pass the state, this state, and print the result. Okay, so here I got the message error counter too high. Okay, because I mentioned here, if counter is greater than 5, then it will raise the error counter is too high. So that's why it is giving us error is too high, error counter is too high. Okay, so that's why it written like this. ठीक है, और यहाँ पर मेमोरी में उसने क्या स्टोर किया, लास्ट एरर काउंटर इज टू हाई. Okay, this one, this is our last error. Okay, he stored the error inside the memory, so this error is going to store here in the memory. Okay, last error means this one. This is the error we got in last. Okay, so last error equals to counter too high, and counter equals to, I provide here 6. That's it. So this example show how to handle error in LangGraph. Okay, the node check, this node check the counter value. If the counter become greater than 5, if counter become greater than 5, it raise an error. Okay, instead of crashing the application, the error is caused, error is caught using the try except. Okay, then error message is saved. Here you can see error message is saved in the memory. Okay, error message is saved, error detail are stored in the memory, and workflow continues safely. So this Mac AI workflow are reliable and stable. Okay guys, and now we have persistence. So persistence means saving the state permanently. Normal state exists only while the program is running. But the persistent, we can save state into file or database. In persistent, we can save the state in file and database. That's it. This allow resuming conversation later. Restore the memory, continuous workflow after restart. Save state, here you can see save state file and load the state later. So in this example we save the state using the JSON. तो गाइस इसमें persistent में क्या हो रहा है, जो हमारा स्टेट है उसको हम सेव कर रहे हैं JSON में, या फिर हम उसको सेव कर सकते हैं फाइल में और डेटाबेस में. ओके, सो इसलिए हम persistent यूज कर रहे हैं. persistent मीन्स सेविंग द स्टेट परमानेंटली. ठीक है, स्टेट है, स्टेट में जो मेमोरीज होती हैं उसको हम सेव करना परमानेंटली विद द हेल्प ऑफ डेटाबेस, फाइल्स और JSON. Okay, so this allow resuming the conversation later. Okay, and restore the memory and continue workflow after the restart. Okay, so here I'm going to pick the code from here. So you can see here import JSON. Import JSON. Import JSON module here used to save and load the data in JSON format. Okay, so here we are going to load data in JSON format with the help of JSON. Here this is the function save underscore state. Okay, here I pass the state and file name state.json. Okay, okay, so open, you can see here with open file name w means read mode h file. So this means open file in write mode. You can see with open file in write mode, f means file. Okay, open file in write mode. Okay, and then you can see here json.dump state and f. Okay, so convert python dictionary here, convert python dictionary into a json and save it into the file. Okay, okay, now we have another function load underscore state. This function is used to load the state from the json file. So file name equals to json state.json, this file. Okay, and here I used try means here this is this try or accept used for catch the error. Okay, so here you can see open file in read mode. Okay, here it is going to open the file in write mode. Here it is going to open the file. Okay, open file in read mode, f means file. Okay, and here read the json data and convert back into the python dictionary. Okay, and read the json data. Okay, and convert back into the python dictionary. Okay, okay, except here you can see except file not found error. If file does not exist, okay, then it will give the error here. Okay, it return the message, empty message, empty disk memory and counters. After this, we can test with examples. So you can see here example state, this one I pass here message, in message I pass here hello, and memory equals to key and values and counter equals to 1. So I use this save state function. Okay, so save the state into the file. Okay, save underscore state and save state, here I pass the this state, so this means save the state into the file. Okay, and load state back in from the file. Loaded equals to load underscore state back, load state back from the file. Okay, and print the loaded state here, print the loaded state. So I'm going to run this. So you can see here in message I got hello, memory equals to key value and counter equals to 1. So this code show the how persistent work. Okay, persistent means saving the state permanently, so data is not lost when the program stop. Okay, so here save state, where is this one, save underscore state, save the data into the json file. It is going to save the data into the state file, and this one, this node load underscore state read the data back from the file. इसमें हमने क्या किया, इसमें जो डेटा था हमारा उसको हमने सेव किया जेसन फाइल में. ठीक है, फिर हमने उस जेसन फाइल को रीड किया. ओके ओके, सो रीड द डेटा बैक फ्रॉम द फाइल. ठीक है, हमने उस जो हमारे जेसन फाइल में हमने डेटा सेव किया था उसको यहाँ पर हम फिर से रीड कर रहे हैं. इफ फाइल डज नॉट एग्जिस्ट, with the help of this we can read the file. Okay, if file does not exist then it will give the error. Okay, it create a default empty state. अगर सब कुछ empty है तो empty state create कर देगा if file not found. Okay, so this helps AI application remember information even after restarting. Okay, so here you can see message equals to hello, memory equals to this one and counter this one. Okay, now we are going to learn human in loop. So human in the loop, sometime AI should not make decision completely on its own. So human may need to review the output, approve the action, provide the extra input. So LangGraph allow human to participate inside the workflow. This is called the human in the loop. Okay, so here you can see AI generate the response, human review it and workflow continue. So guys, यहाँ पर human क्या कर रहा है, AI समटाइम क्या करती है कि वो खुद से डिसीजन नहीं ले पाती है, उसमें ह्यूमन का इंटरप्ट करता है. ठीक है, ह्यूमन क्या करेगा, रिव्यू आउटपुट करेगा, अप्रूव द एक्शन एंड प्रोवाइड द एक्स्ट्रा इनपुट. ठीक है, सो AI रिस्पॉन्स जनरेट करेगा. ठीक है, फिर ह्यूमन चेक करेगा कि वो सही है कि नहीं. अगर वो सही है तो ह्यूमन अप्रूव कर देगा, देन वर्कफ्लो कंटिन्यू हो जाएगा. सो दैट्स इट. हमें इसको बोलते हैं ह्यूमन इन द लूप, अगर ह्यूमन इंटरप्ट कर रहा है तो. ठीक है, सो हियर आई एम गोइंग टू राइट कोड फॉर दिस. ओके, so you can see this is the simple example. This is the node. Okay, so this node allow human interaction inside the workflow. Def human underscore input underscore node. Here I pass the state. Okay, state means uh, flow of memory. Okay, so user input equals to input human input. Okay, so this concept overall call the human in the loop. Okay, so here this is the node. Here I pass the state human input node. Okay, user input equals to input human input, anything. Okay, whatever human want to enter here, and message dot append the user input. So here you can see this line, ask, this line means ask user to enter the input manually. Okay, and this one save the human response into the मैसेज लिस्ट. गाइज यहाँ पर जो मैसेज लिस्ट है, स्टेट मैसेज लिस्ट मीन्स प्रेजेंट स्टेट प्रेजेंट मैसेज लिस्ट. in this it is going to append the user input. Okay, so save the human response into the message list. Okay, and return the updated state. Okay, and then add to the graph. So graph dot add underscore, sorry, add graph dot add underscore node. Okay, so we are going to add this human input node here. I pass here human. Okay, so this, so add this node to into the graph with the help of this line. Okay, and connect this one is connect this node with the other node as needed. Okay, for example, graph dot add underscore edges, so we can write like this. For example, मैं बस एग्जाम्पल दे रहा हूँ कि आप ऐसे भी कनेक्ट कर सकते हो. ओके, graph dot add underscore age, here you can connect LLM human. ओके, सो आप ऐसे भी कनेक्ट कर सकते हो इफ नीड. LLM को ह्यूमन से कनेक्ट कर दिया, एंड देन एक और एग्जांपल दे देती हूँ. ग्राफ ह्यूमन को हमने नेक्स्ट जो भी नोड रहेगा उससे कर देंगे कनेक्ट. ओके, सो दीज आर द एग्जांपल, नथिंग एल्स. ओके, सो this node allow a real human to participate in the AI workflow. Okay, instead of AI making every decision automatically, the workflow can pause and ask for the human input. The human response is then added into the state here. Okay, so human response is then added into the state and the graph continue execution. This is useful when human approval is needed, AI is uncertain, and manual review is required and extra information is needed. Okay, so human in the loop means AI and human work together inside the same workflow. Okay, so now I'm going to move here. Practical extend the question and answer agent. Okay, so guys, we are going to do practical and extend the question and answer agent here. Now we are combining multiple agent concept together. In this example, we save the state, load the previous memory, store the user question, and update the conversation history with the help of LangGraph. Okay, so this create a more realistic AI application. You can see here, load the previous state and user questions. Okay, and add this previous state into the user question and run the LLM node and save update the state and return the response here. Okay, so here I'm going to write code. So here you can see I'm going to import the JSON module here, and I mean JSON for use to save and load the state in a JSON format. I import OS module. Okay, it is used to check if the file exists or not. From langgraph.graph import the state graph. Okay, so I'm just importing langgraph component state graph and is used for the stop the graph. Okay, so state file equals to state.json. Guys, I hope here I have this file. Okay, state.json. With the help of this, previously I will okay, I save here json file, this one. Okay, state.json. So I'm going to use this file here, state.json. Okay, so state file equals to state.json, and you can see here persistence function. So this function is going to save the state. Okay, so file, this is the file name. Okay, file name where state will be stored. Okay, फाइल नेम वेयर स्टेट विल बी स्टोर. सो गाइज ये फाइल का नाम है, जो हमारा अपकमिंग स्टेट्स आएंगे उसको हम इसमें स्टोर करेंगे, नथिंग एल्स. ओके, पहले भी हमने स्टोर किया था, अभी भी हम स्टोर करेंगे, तो डोंट वरी, इट विल ऑटोमेटिकली क्रिएटेड. सो यू डोंट नीड टू क्रिएट बाय योर ओन, just mention here name. Okay, you can see here this is the function. Okay, function to save the current state into the JSON file. Current state we are going to save into the JSON file. Def save in underscore state. Here I put the state. Okay, and here open the file in write mode. So with open state file, this one. Okay, we are going to open this file. Okay, and read. So here we are going file in the read mode. Okay, and json.dump state f. Okay, so convert Python dictionary into the JSON and save it. ओके, सो गाइस, हमने अपनी जो पाइथन की जो कन्वर्ट पाइथन डिक्शनरी, ठीक है, इनटू अ जेसन फॉर्मेट एंड सेव इट. हमने एक फाइल ली. ओके, ओपन फाइल इन राइट मोड हियर विद द हेल्प ऑफ दिस, देन कन्वर्ट पाइथन डिक्शनरी इनटू जेसन एंड सेव हियर. ओके, and now you can see here this is another function to load the previous state from the file. जो हमने इस फाइल में सेव किया था अभी, अब हम उसको लोड करने जा रहे हैं. सो डिफाइन लोड अंडरस्कोर स्टेट. ओके, सो हियर यू कैन सी it is going to check if the state file is already exist or not. If os.path.exist, here I pass the state file. Okay, so it check if state file already exist or not. Okay, and here with open state file in write mode. Okay, and then load here. Open here with the help of this, open and read the file and convert JSON back into the Python dictionary. Okay, and it will return the message, empty message, if file does not exist. Okay, if file does not exist, return the empty default stage. Message also empty, memory is also empty. Okay, now I'm going to create nodes. 1 minute. ओके गाइस, सो अगर फाइल एग्जिस्ट नहीं करती है तो एम्प्टी मैसेज और एम्प्टी मेमोरी ये बाय डिफॉल्ट रिटर्न करेगा. रिटर्न एम्प्टी डिफॉल्ट स्टेट्स. ओके, एंड नाउ आफ्टर this is LLM nodes. Okay, so this is no, these are the nodes. First node, extended LLM node. Here I pass the state. Okay, so this node process user message. Okay, so here you can see state dot set default message. Okay, so it ensure required key exist in a state like message and memory. Okay, it require the ensure required key exist in a state. Okay, and get the latest user message. So user underscore message equals to message, I mean latest message, get the latest message of user, last message of the user. Okay, and then store in the memory, state memory last question, it is going to store here in the memory. Okay, that is user question. So here last question in the, I mean here store last question in the memory. Okay, it is going to store last question in the memory. And then simulate AI response, here you can see response equals to user message, simulate AI response, response equals to answer to the user message. And here you can see state message dot append the response, हमने जो मैसेज है उसमें रिस्पॉन्स अपेंड किया, ऐड किया, और उसके बाद फाइल को सेव कर लिया, स्टेट सेव कर लिया, रिटर्न द अपडेटेड स्टेट. ओके, सेव द अपडेटेड स्टेट इनटू जेसन फाइल, save the updated state into the JSON file and return the updated state here. Okay, and now you can see here graph. Okay, this is the instance of graph. Okay, graph state, here I pass the dictionary, so create the graph using the dictionary state. Okay, and here you can see add a node to the graph, graph dot add a node, here I pass the LLM and extended LLM node, so this is the node I pass here. Okay, and then I set the entry point of this graph, that is LLM. So here you can see this one, this line, create the graph using the dictionary state, and this line add a node to the graph, and this line is entry point or set the starting point, that is LLM. Okay, and graph dot add edges, so here LLM connect here and here. Okay, so end the graph after the LLM node. Okay, app equals to graph dot compile, so compile the graph into the runnable app. Okay, and now load previous state, so initial state equals to load underscore state, so load the saved state from the JSON file. Okay, initial state equals to load state, so load the save state from the JSON file. And here initial state of message I'm going to append here what is LangGraph. ठीक है, तो यहाँ पर न्यू add the new user question into the message, so this is the new user question I'm going to add here into the message at initial state here. Okay, then run the graph, result equals to app dot invoke initial state. Okay, so run the graph with the help of this and print the result, print the updated result. So I got this one is result, message equals to hello, what is LangGraph, so this is the question, what is LangGraph. So I append this here in new message. Okay, and answer to what is LangGraph, memory equals to last question and what is LangGraph and counter one. So guys, here you can see this example show how persistent work in LangGraph. Okay, instead of losing memory after program stops, so we save the state into the JSON फाइल. यहाँ पर हमारी एक जो JSON फाइल है हमने उसमें सेव कर लिया है, हेलो व्हाट इज LangGraph आंसर टू द, सो ये मेमोरी के लिए हमने यहाँ पर आई स्टोर एवरीथिंग हियर इन स्टेट डॉट जेसन फॉर मेमोरी. ओके, ताकि LLM को याद रहे कि इसने ये पूछा था. ओके, so instead of losing memory after after program stops, we save the state into the JSON file. Okay, so you can see here so here we load the previous state at new add the new user message. Okay, and run the LLM nodes and save the updated state and return the response here. Okay, so this allows the AI system to remember previous conversation even after restarting the applications. Okay, पहले हमने यहाँ पर फाइल सेव की, फिर उसको रीड किया. ठीक है, अगर यहाँ पर रीड किया, अगर वो फाइल में फाइल नहीं है तो उसमें एम्प्टी मैसेज और डिक्शनरी एम्प्टी मैसेज और मेमोरी इन डिक्शनरी दे देगा. ठीक है, उसके बाद हमने नोड क्रिएट किए एक्सटेंडेड LLM नोड, यहाँ पर भी हमने 1-2 डब्बे लिए मेमोरी मैसेज और मेमोरी सेव करने के लिए, जो हम स्टेट में हम सेव कर रहे हैं स्टेट डॉट सेट डिफॉल्ट, and here this is for user's last message, and here we are going to store last question into the memory and return the user response here. and हमने यहाँ पर मैसेज को, जो पुराने हमारे ओल्ड मैसेज थे उसमें हमने रिस्पॉन्स को अपेंड किया and save the state here. Okay, and then we create graph, add the node here and set the entry point, and यहाँ पर LLM को एज से कनेक्ट किया एंड द एंड ग्राफ किया, और यहाँ पर हमने ग्राफ कंपाइल कर दिया. ओके, एंड लोड द प्रीवियस स्टेट, यहाँ पर हमने लोड प्रीवियस स्टेट किया और यहाँ पर यूजर क्वेश्चन को ऐड किया न्यू मैसेज में एंड यहाँ पर रन किया. दैट्स इट. और फाइल में हमने सब कुछ सेव कर लिया. दैट्स व्हाई इट विल रिमेंबर. ओके, so these intermediate concepts are make LangGraph suitable for AI application because real world AI system need memory, error handling, persistent, multiple agent and human interaction. Okay guys, so bye bye, take care, see you in next video. So hello guys, we are going to move here in file number 404 hands-on build.ipy env file. Okay, so this is our last file, hands-on build. After this we will create 4 project. Okay, so don't worry about it. Okay, so hands-on build complete AI agent. So now we will build a complete AI agent step by step using a LangGraph. In this project, our agent will take a user input, decide what action to take, and use either an LLM or a tool, store the memory and return the final response. This is how real AI workflow system are designed. Okay, so हम यहाँ पर क्या करने वाले हैं, एक प्रोजेक्ट बनाने वाले हैं जिसमें हमारे एजेंट, बहुत सारे एजेंट भी हो सकते हैं और नोड भी बहुत सारे हो सकते हैं, और एजेंट यूज़र के इनपुट को लेगा, देन डिसाइड करेगा कि कौन सा एक्शन लेना चाहिए. अब मुझे LLM यूज करना चाहिए और टूल यूज करना चाहिए. सो इस टाइप का डिसीजन हमारा एजेंट लेगा एंड वो स्टोर करेगा मेमोरी में एंड फाइनल आंसर रिटर्न करेगा. ओके, सो इस तरह से हमारा AI वर्कफ्लो यहाँ पर हम डिज़ाइन करेंगे. ओके, सो प्लानिंग द एजेंट. बिफोर राइटिंग कोड वी फर्स्ट प्लान द वर्कफ्लो. आवर एजेंट नीड टू accept user input and decide whether to use LLM or tool, and generate the response and save the conversation into the memory and return the final output. So this is our agent need to do. Okay, and workflow and design, you can understand the workflow looks like this: user input and then decide by the agent that I should use LLM or tool, and then it take one decision, like that I'm go for tool, and then memory will update here and then generate the output here. This is the decision based workflow, not just a simple linear chain. Okay, so we are going to build a component here. Okay, so here I'm going to define the state, node and edges. Okay, so first define the state. State here, class equals to agent state, user equals to user input equals to string, response should be string, memory should be in list, need tool equals to bool, and confidence equals to flows. So guys, these are the variables I'm going to use. User input, response, memory. Need tool means कौन सा tool हमें use करना चाहिए, कौन सा नहीं. Confidence float. Okay, so this one is used for store the user question, and this one is used for store the final response, and memory is used for store the conversation history. Need tools mean decide whether tool is needed or not. Float, confidence float means store the confidence score. Okay, so this state store all the important information used by the agent, user import, final response, memory. Okay, need tools, routing decisions here, need tool and confidence. So every node will read or update this shared state here. Okay, now we are going to create the nodes here. So I already have code for nodes. These are our multiple nodes, guys. The multiple nodes, I'm just explaining one by one. Okay, this one is first node. This one is first node, input node. Okay, def input underscore node. Here I pass this state. Okay, this not this one. Okay, here I pass the state that it will use for share the information. Okay, so here you can see take the user input from the terminal. Okay, state user input. So we are going to take the user input from the terminal and return the state here. Input node में क्या हो रहा है, just user से input लिया जा रहा है, that's it, nothing else. Okay, so this node collect the user input and store it inside the state. Okay, यहाँ पर store कर रहा है inside the store state. Okay, and here you can see we have decision node. Okay, decision node def decision underscore node, here I pass the state. It decide if need tool or not. Okay, so you can see here decision nodes, here I use keyword. Okay, keyword that require tool support, FAQ, help and support tools. Okay, so यहाँ पर देखो आपने state need tools means जो current tool है, here you can see this is this line keyword state require the tool support. Okay, and this line need underscore tool, so it check whether input contain these keyword or not. ओके अगर यूज़र ने इनपुट दिया और इट इज़ गोइंग टू चेक कि हमारा जो की जो यूज़र इनपुट है वो इन कीवर्ड को सपोर्ट कर रहा है कि नहीं. सो एनी वर्ड इन द स्टेट यूज़र इनपुट. ठीक है, तो स्टेट यूज़र का जो इनपुट होगा उसमें से इसमें से कोई वर्ड है या नहीं है. ठीक है, उसको वो लोअर केस में कन्वर्ट करेगा, फिर वो चेक करेगा कि जो कीवर्ड में है वो वर्ड्स यहाँ पर जो कीवर्ड में जो वर्ड है वो यूज़र इनपुट में है या नहीं है. ओके, सो इट इज़ गोइंग टू चेक हियर. Okay, check whether input contain these word or not. Okay, here. Okay, then confidence score equals to 0.8 if state need tool, else 0.6. What does it mean? This is the confidence score. Okay, confidence score equals to 0.8. Okay, otherwise if state need tool, हमारा जो कॉन्फिडेंस है इसका स्कोर 0.8 होगा अगर वो उसको नीड होगी टूल की. अदरवाइज कॉन्फिडेंस विल बी 0.6 एंड इट विल रिटर्न दी अपडेटेड स्टेट. ओके, सो दिस टूल this node decide whether the workflow should use a tool or a LLM. If the user input contain keywords, if user input contain keyword like FAQ, help, support and tool, okay, then the graph route to the tool node. Okay, then graph route to the tool node. Okay, now we have LLM nodes. You can see here LLM def LLM underscore node, here I pass the state. Okay, simulate LLM response. So you can see here this one is used for LLM response node. Okay, and this line simulate LLM response. So create a context using the previous memory. Okay, context equals to it is going to create context by using previous memory. Okay, like import response. Okay, and using the previous memory from last message to minus to the last message, from minus 2 to the last. So with the help of this it is going to create the context using the previous memory. Okay, so here you can see under join user input. Okay, user input and user response, user input and response, it is going to take from the memory and create the context using the previous memory. Guys, इसने input उठाया memory से and response उठाया और उसके हिसाब से ये previous memory को उठा के उसका context create कर रहा है यहाँ पर. ठीक है, nothing else. And here state response in current state. Okay, so response equals to LLM answer. Here it is going to provide the answer from the context from last 50. Okay, from 0 to 50. And state equals to user. So this line means generate the LLM response. Okay, so here it is going to generate the LLM response by using this context and user input and return the updated state. Okay, so this node, LLM node, generate the AI response. It also use the previous conversation history as the context. This helps to create more intelligent and contextual answer. Okay, and here you can see def tool underscore node, here I pass the state. Okay, so this node I'm going to create. Okay, tool underscore node, here I pass the state, simulate the tool. Okay, so we have frequency, ask, response, FAQs. Okay, FAQs, visit our website for common question, help, contact for support, and support we are here to help, and tool. So guys, this is like response. Okay, so this is our tool, def tool node. Okay, and with the help of this line, match the user query with the keyword. Okay, for key and response in a frequency, this one frequency response dot item, we are going to match our key, okay, in the from the user import. Okay, okay, so here match the user query with the keyword and save. Here you can see save the matching response. Okay, state response equals to response. So यहाँ पर उन्हें save the matching response and break. Okay, otherwise here response equals to tool no specific help found, find out and return the state. Okay, so here this is the tool, this one. So this node simulate a tool call. This node simulate a tool call. Instead of using an LLM, it directly return the predefined response. यहाँ पर ये LLM यूज नहीं कर रहा है, यहाँ पर ये क्या कर रहा है, डायरेक्टली predefined response यूज कर रहा है. Okay, so it is going to use predefined response instead of LLM. Okay, this is useful for FAQ, help, support and tool. Okay, so this node simulated tool call. So यहाँ पर एक tool call के लिए ये node बनाया गया है. ठीक है, इसमें इस टाइप के आंसर दिए जाएंगे. अगर आप फ्रीक्वेंसी, आस्क, हेल्प, सपोर्ट, टूल से रिलेटेड क्वेश्चन पूछ रहे हैं तो ये कीवर्ड मैच करेगा और इसको सेव करेगा. ओके, देन जनरेट करेगा. अगर नहीं मिलेगा तो बोलेगा टूल नो, आई मीन नो स्पेसिफिक हेल्प फाउंड. ओके, एंड आफ्टर दिस वी हैव अनदर नोड, मेमोरी नोड. हियर आई पास द स्टेट. ओके, दिस इज अवर मेमोरी नोड, memory update node. Here state memory dot append import state user input and response equals to state response. Okay, so memory dot append input equals to state user input and response equals to user response and return the state. So here this node store the conversation history in the memory. Okay, previous question, previous response. You can see here state memory. In memory it is going to store user input, okay, previous question and previous response. You can see here previous response and previous input. It is going to store inside the memory and return the updated state. Okay, so these are our nodes, guys. Okay, so here we are going to build the graph. So now we connect all nodes together. Okay, so for example, here I mention connect all node together. First one is input. First one is input, and then input, and then decide, and then decide that agent need to use tool or LLM, and then store inside the memory, and then it is going to end here. So guys, here we are going to define, we are going to connect all the nodes together like this: input, decision nodes, tool or LLM, and then memory, and then end. Okay, so after tool, you can see here we are moving here in conditional routing. Okay, so this routing function control the workflow path. Okay, if tool is needed, go to the tool node, otherwise go to the LLM node. ठीक है, अगर उसको tool लग रहा है तो tool यूज करेगा, otherwise वो LLM node यूज करेगा. Okay, so router, this is the function, router function. Here I pass the state for memory. Okay, flow of memory, decide next node. Okay, return tool. Okay, it is going to return tool. Okay, if state need tool, otherwise it will return the LLM. That's it guys. Okay, so यहाँ पर क्या हो रहा है कि वो अगर यूजर क्वेश्चन पूछेगा तो पहले वो टूल देखेगा, तो टूल अगर रिक्वायर्ड है तो वो टूल यूज करेगा, अदरवाइज वो LLM यूज करेगा. ओके, सो हियर यू कैन सी आफ्टर दिस routing the function, now we can see here testing component before running the full graph. Okay, before running the full graph, we test individual nodes separately. This helps us to find the bugs, verify the output, and debug the faster. Okay, so you can see here these are the test decided test decide node. Okay, so here you can see testing decide underscore node. Okay, so you can see here test underscore state. Here I pass the user input, and user input I pass here I need help. Okay, and need underscore tool, here I pass the false and confidence equals to 0. Okay, so this simulate user asking for help. This one is going to be simulate for user asking the help. Okay, so this simulates user asking for the help. Okay guys, so here we create the sample test state. Okay, so result equals to decide underscore node. I use here decide underscore node. Where is it? Decide underscore node, this one. ओके, सो मैंने यहाँ पर एक टूल यूज किया डिसाइड अंडरस्कोर नोट्स. यहाँ पर मैंने टेस्ट स्टेट पास किया. इन टेस्ट स्टेट आई यूज यूजर इनपुट आई नीड हेल्प and need tool false and confidence equals to 0 and return the decide result and result. Okay, so this is our first test stage, and then we have test tool node. Okay, so test underscore state 2, here you can see I pass here user input. Okay, I pass here user input. Okay, and here I pass FAQ and response is empty as of now. Okay, result 2, this is result 1 and this is result 2. I use tool underscore node. ओके, यहाँ पर मैंने टूल अंडरस्कोर नोड यूज किया दिस वन, क्योंकि उसने FAQ पूछा ना, बिकॉज दिस इज आस्किंग FAQ. ओके, okay, so here you can see user input FAQ response. So result 2 tool node I'm going to use here. Here I pass this test stage 2. Okay, this one, and print the tool result. Here I pass the this result 2. तो यहाँ पर guys tool required होगा और यहाँ पर tool required नहीं होगा, बिकॉज यूजर इनपुट क्या है I need help. ओके, सो नीड टूल यहाँ पर इसने हमने फॉल्स कर दिया, तो ये टूल यूज नहीं करेगा, ये LLM यूज करेगा. और यहाँ पर ये टूल यूज करेगा बिकॉज आई यूज हियर यूजर इनपुट इक्वल्स टू FAQ. और ये FAQ कहाँ है हमारा? वी हैव FAQ इनसाइड दिस टूल नोड. ओके, यू कैन सी हियर FAQ. तो ये चेक करेगा फर्स्ट कि यूजर क्या पूछ रहा है. इट इज गोइंग टू चेक दैट यूजर व्हाट यूजर आस्किंग हियर. ओके, फर्स्ट क्वेश्चन इज आई नीड हेल्प और नीड अंडरस्कोर टूल इज फॉल्स है, यहाँ पर कॉन्फिडेंस 0 है. तो यहाँ पर डिसाइड करेगा कि इसको क्या यूज करना है. यहाँ पर एक टूल यूज करेगा एंड यहाँ पर एक नहीं करेगा. ओके, सो यहाँ पर ये क्या करेगा? प्रिंट द अपडेटेड रिजल्ट. ओके, सो सिंस input content help here, you can see here help, so need tool should become true. Okay, expected behavior, since input sentence contain the help here. Okay, so need tool should become true here. Initially we have false here. Okay, and testing tool second, for second we have FAQ. Tool node should return the predefined FAQ, this one. So we are testing nodes individually here. This is called the unit testing. Instead of running the full graph, okay, instead of running the full graph, we test the small part separately. Okay, so easier debugging, faster error detection, and verify the node logic. Okay, first check the decision node routing here. Okay, and then second check the tool node response. So here it is going to print decision route I need help. अब इसमें देखो हेल्प है, फर्स्ट वन में हेल्प है, तो यहाँ पर ये हेल्प टूल यूज कर लेगा. ओके, देन इन सेकेंड यू कैन सी हियर FAQ. सो FAQ वाला स्टेप टूल यूज कर लेगा, वही वाला, दिस वन. विजिट अवर वेबसाइट फॉर कॉमन क्वेश्चन एंड हेल्प support@company.com. आपको उस पर कॉन्टेक्ट करना है. इट इज सेइंग लाइक दिस. सो देख लो गाइज, So this is first one and this is second one. Visit our website for common question. So यहाँ पर उसने डिसीजन लिया, डिसाइड रिजल्ट, ओके, कि कौन सा उसको यूज करना चाहिए और कौन सा यूज नहीं करना चाहिए. देन इट विल यूज द FAQ and response generate here. Okay. Now common issue, state not updating. Okay, check the return statement, node not connecting, verify the node name. Okay, and conditional routing fail, check the routing function output. Okay, आपको एक common issue देखने को मिलेंगे तो आप ये सब करना है. Okay, state not updating means you need to check return statement, node not connecting, verify the node's name, conditional routing falling, check the routing function output. Okay, so now we are going to create full agent here. Okay, so here I'm just going to copy from here. Okay, so if you don't install LangGraph, then you can install by using this command. Okay, I just commented out, sorry, I just comment this because I don't want to install, I already install. Okay, from langgraph.graph I'm going to import is state graph and end. Okay, so import state graph to the build workflow graph. Okay, and end is used to stop the graph execution. Okay, and here you can see create the graph. So here this one, create a graph using the dictionary based on the state. Okay, so graph equals to state graph dictionary. So we are going to create graph using the dictionary based state. Okay, so state graph, inside this we have dictionary. Okay, we can create graph only like this. Okay guys, yes, ही create करते हैं. Okay, then we need to add the node, graph dot add a node, input node. This is the input function. I already have this one. We just going to connect the input node, decision nodes. Okay, one by one here, every nodes, LLM node, tool node. Okay, so guys, you can see here we are going to add nodes here, decision node, LLM nodes, tool node and memory node. ओके मैंने यहाँ पर जो ऑलरेडी फंक्शन बनाए थे उन नोड्स को यहाँ पर ऐड कर लिया और मैंने उस ग्राफ का आई जस्ट ऐड ग्राफ एंट्री पॉइंट. ओके, ग्राफ डॉट सेट अंडरस्कोर एंट्री अंडरस्कोर पॉइंट मैंने यहाँ पर इनपुट डाला. Okay, so create a entry point for the graph. Okay, so here, okay, one minute, this one is take the user input, this one decide the next action, this one generate the AI response, and this one execute the tools, and this one is used for store the conversation history. Okay, and this one set entry point input. Okay, so this graph execution start from the input node. Okay, graph dot set entry point input. Okay, and graph dot edges I pass, I add input with the decide node. Okay, so workflow always goes to the decision node. यहाँ से input आया हमारे पास और input कहाँ जा रहा है, decision node में. Okay, और वो decide करेगा decision node. Where is decision node? This one. यहाँ पर आएगा, वो डिसाइड करेगा कि उसको LLM नोड यूज करना है, देन टूल नोड यूज करना है या टूल नोड यूज करना. सो डिसीजन नोड इज डिसाइडिंग हियर दैट इट इज गोइंग टू यूज टूल नोड और LLM node. Okay, so after this router function, this is the router function. Okay, router function, this function decide next path dynamically. Okay, so if tool is needed, go to the tool node. Okay, if tool needed, go to the tool node, otherwise go to the LLM node. Okay, so return tool if need the tool node, otherwise it will use LLM node. Okay, and conditional routing you can see here, after decide node here after decide node we are going to use conditional routing. Okay, so graph check, after decide node graph check router result, this result. Okay, after decide node graph check the router result. Okay, so here you can see graph dot add conditional edges. Okay, so it is going to after decide node. Okay, so after decide node it is going to check the router result here. Okay, router result here and choose next node dynamically. ठीक है, यहाँ पर क्या करेगा, choose next node dynamically. Graph dot age conditional age decide and router. Here it choose करेगा कि मुझे tool use करना चाहिए, node tool और LLM. Okay, that's it, nothing else. And then after this we have next step. Okay guys, so in next step you can see here, after deciding we need to use tool or LLM. So in next step we are going to add the ages. Okay, so after LLM response, save the memory here, graph dot age edges. So LLM memory is going to store here, and graph dot age add age tool memory is going to store here. So we just save the memory of tool and LLM. Okay, after tool response, graph dot age memory, it is going to end here. 1 minute. So graph end here, graph end here, graph end after the memory update here. Okay, and then we need to compile app equals to graph dot compile, and we are going to run this. Initiate state equals to, we are written here user input. User input is what is AI. Okay, initially state is response is empty, memory is also empty, no need tool is equals to false, and confidence equals to 0. So guys, this is our starting state for the graph execution. Okay, starting state for the graph execution. And here you can see invoke the graph. So result equals to app dot invoke. Here I pass the initial state and print the result. So it is going to return the final result. Okay, so you can see here user input, it is giving us empty. What happening guys? 1 minute. I just copy and paste it here, same to same things, nothing else. Okay, I use node here, set entry point. Okay, and decide and route, and use conditional edges, and next, and then end here and compile the graph. Initial state, I am going to rerun this. Okay, so this is our answer. What is an AI? Response, context, memory, need tools, false. Okay, 1 minute. So this is guys the complete graph workflow. Okay, so 1 minute. Here I can explain inside this. We have user input, we have input, then it is going to take decide, that we need to use tool or LLM. Okay, then it is going to update the memory, and then generate the and then end here and generate the final result. 1 minute. So guys, I just comment this line. मैंने ये लाइन कमेंट कर दी है because there is no need of giving this line here. Enter your query in import node. Okay, I just written here import node and return the state. Okay, तो हम import node यहाँ पर directly देंगे, means import we are giving here directly. Okay, so after this we have here user input equals to what is AI. Okay, because अभी हमारा correct answer नहीं आ रहा था, I just comment import node. Okay, in import node I just comment the user input over there. Okay, and you can see here user input equals to what is AI. Okay, and response equals to LLM answer. So what is AI? Correct, because input passed properly here. Okay, and what is AI? So it is not going to use the tool, so that's why to use tool false. new tool false, this one, because this does not contain frequency, FAQ, help and support and tool. Okay, and confidence equals to 0.6. So you can see here LLM answer what is AI. This one, LLM answer what is AI. So your LLM node is just simulating output, not real model call, so it's fine. Okay, and here memory, you can see here this one is memory. Okay, in memory it is going to store what is AI and response of this. Okay, so memory node is working perfectly, store the input and store the response, and confidence equals to 0.6 means expected behavior from your logic, from our logic. Okay, state confidence equals to 0.8 if need tool. Okay, अगर हमें टूल नीड की जरूरत है, then it will use 0.8, otherwise it will use 0.6 confidence. Okay, this one, confidence equals to 0.8 if need tool, otherwise it will give you 0.6. So it is also working. Okay, this one is also working here. Okay, so everything is now working correctly, routing, state, memory and response. Okay, so now you can see unit test. I already defined these tests here, testing and debugging, this one and this one. Okay, so guys, here this is simple. User asked the question, what is AI? Okay, this is our user question, what is the AI, and graph check if tool is needed or not. Okay, so it use the LLM node, LLM generate the response, memory stored the conversation, and final state is written. Okay, and this is for unit test. So here you can see decide test decide node, state equals to I pass user input, help me and need tool equals to false. So result equals to, it is going to use decide decision nodes, and here it is going to put the state. Okay, asset result need tools equals to true. So 1 minute, these are also like test, unit test, this one. Okay, so these are the simple unit tests for LangGraph node. These tests are used to check if each node is working correctly or not. Okay, so this function check for decision nodes. Okay, state equals to I pass the create sample input state. Okay, and state equals to user input, and need tool equals to false means initial value, LLM will be updated. Okay, and user input equals to help me contain the keyword help. Okay, so yes, we have keywords contain, sorry, help inside the node. You can see here inside the node, yes, we have help keyword. Okay, and result equals to I use decision nodes, and here I pass the state, and asset result equals to need underscore tool. So run the decision node with the help of this we can run the decision node, result equals to decision node state, and asset check if the tool decision become true or not. Okay, check if tool decision become true, if not test will fail. Okay, print decision test pass. Okay, and def test memory tool. So test for memory node, test underscore memory underscore node, state equals to user input test, response equals to answer, memory equals to input, result equals to memory node state. So यहाँ पर मैं memory node use कर रही हूँ guys. I have memory nodes, this one, memory nodes and tool nodes and decision nodes. So we are going to use these kind of nodes. तो यहाँ पर भी मैंने यूज़र इनपुट दिया, रिस्पॉन्स आंसर एंड मेमोरी अभी एम्प्टी है. तो यहाँ पर मैं मेमोरी नोड यूज़ कर रही हूँ. यहाँ पर मैंने स्टेट पास किया है, डिटेल ऑफ यूज़र रिस्पॉन्स सॉरी यूज़र इनपुट रिस्पॉन्स. ओके, एंड मेमोरी एसेट लेंथ ऑफ रिजल्ट. यू कैन सी हियर लेंथ ऑफ रिजल्ट ऑफ मेमोरी इज इक्वल टू 1. जो रिजल्ट आएगा मेमोरी से उसकी लेंथ अगर 1 हो गई तो प्रिंट मेमोरी टेस्ट पास. ओके, देन वी आर गोइंग टू कॉल दीज टूल्स मेमोरी टेस्ट डिसाइड एंड टेक्स्ट memory decide. So here you can see I got the result, decide test pass and memory test pass. Okay. Okay, so we are checking two things here. One decision. Okay, one decision mode node test input content help me. So it should test set input need. Sorry, it it should array yaar, sorry. So here we are checking two things. One decision node test. This is the decision node test. Input content help me. You can see here help me. So it should set need underscore tool equals to true. Okay, and then print decision decide test pass. And second we had text underscore memory underscore tools. Okay, memory node text. So state equals to, you can see here I have these things. Okay, so it should store one record in memory. If both tests pass, it means our node are working correctly. Okay guys, so everything is finished now. These are tests. Okay, and summary, in this project we build the complete workflow using the LangGraph. We learn here state management, nodes, conditional routing, memory, graph assembly and testing. This is the foundation of the real AI agent and foundation systems. Okay guys, if you have doubt you can ask me in comments. Now we are going to build our projects. Okay, so after module 4 we are going to build our project AI story waiver, and these are 1 2 3 4 project are there. So now you can see here I'm going to one project, sorry, I'm going to create one project, smart underscore support underscore agent dot py. This is the file name. I'm going to create one project here. I'm going to close this left side. Okay, so this is the smart support agent built using the LangGraph. Okay, so user give the input, graph decide use the tool or LLM. Okay, LLM or tool generate the response, memory store conversation history, Streamlit show chat UI, and graph can loop if response is not good enough. Okay, so we are going to build this. User give the input and graph decide that I need to use tool or LLM. Okay, an LLM or tool generate the response, and memory stores conversation history. Streamlit show the chat UI, and graph can loop if response is not good enough. Okay guys, so this is the project I'm going to build here. I'm going to import some basic things here. Okay, so you can see here I'm going to import Streamlit as st, okay, for UI. And from langgraph.graph I'm going to import state graph and end for graph. Okay, and from LangChain underscore OpenAI I'm going to import chat OpenAI. Okay, and from .env I'm going to load .env, that we will get our API key from this file. Okay, okay, and from typing I'm going to import typing dict and list. Okay, so type dict for data. Okay, and import the OS for data validation, this one. Okay, and I'm going to import the OS also. So load the environment variable from .env file. Use for API key like open router API key, Groq API key, etc. So I use load underscore env. Okay, so now we are going to set up our UI setup with the help of Streamlit. Okay, so set page title and icon in browser tab. So you can see here we can set st means Streamlit. Okay, so we already import Streamlit as st. Okay, so st dot page underscore, sorry, set underscore page underscore config. Here I pass the page title smart support agent. Okay, and page icon this one. Okay, so main title show on UI. So st dot title support स्मार्ट सपोर्ट एजेंट, ये वाला टाइटल हमें यूआई पे दिखेगा. st markdown langgraph plus open router. That's it. Now I'm going to create code for states. Okay, so you can see here. Okay, so you can see here after main title on UI we are going to define state definition, agent, memory, and structure. Okay, so this is the class define the what data move inside the graph with the help of pydantic. Okay, pydantic used for data validation here. Sorry, typedict also inside the pydantic. Okay, so user input should be string. This is the user question. Response in string. Okay, this is provide the answer by the model or tool. Okay, and memory should be in list of dictionary. Okay, so it will store the chat history. Need underscore tool bool means decision tool needed or not. Okay, and loop count integer means how many time loop happen. Okay guys, so this is our first class, okay, of agent state. ठीक है, so this decide what data move inside the graph. Okay, with the help of state we need to know like flow of flow of the memory or flow of the data inside the graph. ओके तो हमें पता चलेगा कि कौन सा डेटा कहाँ कैसे फ्लो हो रहा है ग्राफ विद द हेल्प ऑफ दिस एजेंट स्टेट. ओके, नाउ वी आर गोइंग टू क्रिएट नोड्स. Okay guys, so first node is input node, this one. Okay, just pass the state forward, no processing here. So यहाँ पर मैंने क्या किया, define input node. Here I just pass the state and return the state. ठीक है, flow of memory, flow of the information, just इतना ही pass किया है. Okay, and in decision node you can see here decide whether we use tool or LLM. Okay, so def decision underscore node, here I pass the state. Okay, if user message contain these word, use tool. Okay, so you can see here present node underscore need underscore tools. Okay, state means flow of the information, flow of the memory. Okay, flow of the data. तो यहाँ पर शो करेगा need underscore tool अगर हमें चाहिए. Okay, so need underscore tool is equals to any word in state like user input dot lower for word in FAQ, frequency, support and help. ओके, एंड रिटर्न द स्टेट. इसका मतलब है कि हम जो डिसीजन हमारा टूल है, ठीक है, उसमें अगर वो नीड टूल अगर ग्राफ को अगर नीड टू मतलब यूज वो ग्राफ टूल को यूज करना चाहता है तो वो उसमें चेक करेगा कि जो यूज़र इनपुट है, ओके, वर्ड एंड स्टेट यूज़र इनपुट, ठीक है, जो यूज़र का इनपुट है, ठीक है, उसमें जो वर्ड हैं, ओके, वी हैव यूज़र इनपुट, ओके, एंड देन वी चेक द यूज़र इनपुट्स वर्ड. ओके, वर्ड इन यूज़र इनपुट. ओके, सो अगर हमारे पास वर्ड है, इफ वी हैव वर्ड लाइक FAQ, हेल्प, सपोर्ट्स इन अ यूज़र इनपुट वर्ड. ओके, अगर हमें ये वाले वर्ड यूज़र इनपुट में मिल रहे हैं तो वो टूल यूज करेगा एंड देन रिटर्न द अपडेटेड स्टेट. ओके, नाउ वी हैव दिस कोड. Okay, after decide node we have LLM node. Okay, LLM nodes. Okay, here I pass the state. So guys, this tool is used for decision like I need to use tool or not, or I should need to use to LLM node. Okay, so define LLM node. Here I pass the state. So here LLM equals to chat OpenAI. Here I pass the model name. I use DeepSeek this one slash DeepSeek hyphen chat. And here I pass API key os.getEnv. I pass here open router API key. Okay, and here I giving URL that for get the API. Okay, if you don't have API, you can create your API key and put here into the env file. Okay guys, so here I already mentioned Groq API key, but you can mention here open router key like this. Okay, open underscore router underscore API underscore key. Okay, so you can put here your own open router API key here. Okay, so after this build the context from last 3 chat memory. Okay, so context equals to dot JSON. So import, I'm going to take here user import and response. Okay, and last message. Okay, so it is going to take the last user message, input, user input or its response from the memory, from m in the state of memory. इसमें क्या हुआ, इसने यूजर का जो लास्ट इनपुट है और रिस्पॉन्स है वो लिया मेमोरी से और वो उससे कॉन्टेक्स्ट जनरेट किया. बिल्ड द कॉन्टेक्स्ट फ्रॉम लास्ट 3 चैट फ्रॉम द मेमोरी. Okay, and then prompt sent to the LLM. Prompt equals to F in doc string I pass the context and user question state user input. So here you can see prompt equals to context, this one. context में क्या क्या है, user का input है, response है from the memory. Okay, so user question here, this is a prompt. Okay, and user question I pass here user input. Okay, and give the helpful answer here, this is the instruction. Okay, and get response from the model. Response equals to llm dot invoke prompt. I pass this prompt here. Okay, inside this we have user input. Okay, and save the response in the stage. Okay, state response equals to response dot content. Store the conversation in the memory. So state memory dot append equals to input. So here I pass the input, user input, and response equals to, so this one is response. Okay, so यहाँ पर हम क्या कर रहे हैं, स्टोर द कन्वर्सेशन इन द मेमोरी. हमने यूजर इनपुट और यूजर रिस्पॉन्स जो हमें मिला मॉडल से वो हमने यहाँ पर स्टोर कर दिया मेमोरी में, और मेमोरी को मेमोरी को में डाल दिया ये सब रिस्पॉन्स एंड यूजर इनपुट. ओके, एंड देन रिटर्न द अपडेटेड स्टेट. ओके, हमने यहाँ पर क्या किया, हमने कॉन्टेक्स्ट लिया यहाँ पर एज अ इनपुट. दिस इज द कॉन्टेक्स्ट जो पास्ट जो लास्ट 3 यूजर इनपुट एंड रिस्पॉन्स से मिलके बना हुआ है, और हमने यहाँ पर प्रॉम्प्ट में एक यूजर इनपुट दिया. ओके, एंड यहाँ पर गेट द रिस्पॉन्स फ्रॉम द मॉडल. यहाँ पर हमें रिस्पॉन्स मिल रहा है और मॉडल से हमने यहाँ पर प्रॉम्प्ट पास किया तो उससे हमें रिस्पॉन्स मिल रहा है. देन वी आर गोइंग टू सेव द रिस्पॉन्स हेयर. ओके, इन स्टेट, एंड देन store the input and response in the memory, and here we need to update the state. Now you can see here we are going to check satisfaction. Okay, loops and satisfaction check. Okay, so this is the function check underscore satisfaction. I pass here state. Okay, increase the loop counter each time. Okay, state I have here one variable loop underscore count increase by the 1. अगर आपको रिस्पॉन्स सेटिस्फाइड नहीं हो तो आप बार बार लूप करके चेक कर सकते हो. इंक्रीज द लूप काउंटर 1 टाइम. ओके, सो इफ रिस्पॉन्स स्टिल अनक्लियर and loop is less than 3, then retry decision. Okay, if question in state response, okay, if question in response and loop count is less than 3, then return the decide. Okay, and otherwise stop the graph here. Okay, with the help of end. तो यहाँ पर अगर आपको सेटिस्फैक्शन जो सेटिस्फाइड रिस्पॉन्स नहीं मिला है और अनक्लियर है तो आप अगेन रिट्राई कर सकते हो. ओके, सो विद द हेल्प ऑफ दिस. Now you can see here we are going to set LangGraph. Okay, LangGraph setup. So create a graph with a state structure. Graph equals to state graph. Here I pass the agent state. Okay, this one. Where is the agent state? This one. सो गाइज यहाँ पर मैं LangGraph का सेटअप करने जा रही हूँ. यहाँ पर मैंने स्टेट पास किया. ओके, देन आई एम गोइंग टू ऐड नोड टू द ग्राफ. फर्स्ट ग्राफ डॉट ऐड नोड. हियर आई पास द इनपुट एंड देन इनपुट नोड, एंड हियर अगेन आई एम गोइंग टू ऐड अनदर ग्राफ ऐड अंडरस्कोर नोड. सो यहाँ पर मैंने ऐड अंडरस्कोर नोड एंड ऐड अंडरस्कोर नोड. विद द हेल्प ऑफ दिस आई एम गोइंग टू ऐड द नोड. ओके, सो input node, decide, decision nodes, LLM nodes, and tool underscore node. So these are the nodes, guys. Okay, decide node, input nodes, LLM nodes. Okay, so these are the nodes I am going to use here. Okay, and then entry point first node. Okay, so graph dot set the entry point input. तो ग्राफ में क्या होता है, जो सबसे पहला नोड होता है उसको एंट्री पॉइंट बना दिया जाता है ग्राफ में. ठीक है, तो मैंने इनपुट जो नोड था मैंने उसको एज अ सेट कर दिया एंट्री पॉइंट. ओके, ऑलवेज गो फ्रॉम इनपुट टू डिसाइड. ओके, सो नाउ वी आर गोइंग टू कनेक्ट दिस एजेस बिटवीन इनपुट नोड टू द डिसाइड नोड. ओके, सो ग्राफ डॉट अंडरस्कोर एजेस इनपुट डिसाइड. सो यहाँ पर मैंने इनपुट को डिसाइड से कनेक्ट कर दिया. ओके, सो ऑलवेज गो फ्रॉम इनपुट नोड टू द decision node here. Okay, and here I use the conditional routing. Okay, if need tool true, it is going to use the tool node. Okay, else LLM nodes. Okay, so graph dot add अंडरस्कोर कंडीशनल अंडरस्कोर एजेस. ओके, तो यहाँ पर हम कंडीशन रखेंगे. सो आई यूज डिसाइड. ओके, इट इज गोइंग टू डिसाइड okay whether it is going to use need tool or llm. Okay, so here I use lambda x. It is going to tool if need tool, otherwise it will going to use llm. Okay, so after llm or tool, check if we need tool or end. Okay, so graph dot add conditional edges llm check satisfaction, this one आई यूज दिस फंक्शन. ठीक है, अगर हमें रिस्पॉन्स सही मिल रहा है हम चेक सेटिस्फेक्शन करेंगे. अगर वो सेटिस्फाइड है तो एंड हो जाएगा, अदरवाइज वो स्टिल रिट्राई करेगा. ओके, सो आफ्टर LLM और टूल चेक इफ वी नीड टू लूप और एंड हेयर. ओके, सो ग्राफ डॉट एड कंडीशनल एजेस LLM चेक सेटिस्फेक्शन, दिस वन. ओके, यहाँ पर वो चेक करेगा कि रिस्पॉन्स सही है कि नहीं है. अगर रिस्पॉन्स आई मीन लूप काउंट स्टिल लेस देन 3 देन वी कैन रिट्राई. ओके, here and graph dot add underscore conditional underscore edges tool check underscore satisfaction. Okay, now we are going to compile the graph into the runnable app equals to graph dot compile. Now we are writing this one Streamlit session memory. Okay, so store the chat history in UI session if memory not in st.session underscore state. So st.session underscore state dot memory equals to empty list. Okay, so store the chat history in the UI. Okay, so यहाँ पर अगर memory store नहीं है in the session then it will store the memory in the session like this. Okay, as of now it is empty. After this, like if you are going to search then it will store here. Okay, so store loop counter in the session if loop count not in st.session underscore state then st.session underscore state loop count is equals to 0. तो यहाँ पर लूप काउंट नहीं है तो वो उसको स्टोर करेगा. ठीक है, लूप काउंट नॉट इन द सेशन देन st.session डॉट लूप काउंट इक्वल्स टू 0. अगर लूप काउंट नहीं है सेशन में तो वो 0 होगा. दैट्स इट. Now we have user import. So you can see here user input. Okay, so user equals to st dot text input equals to ask something. Okay, so ये UI पे बनेगा guys और ये आपसे क्वेश्चन के लिए पूछेगा. ठीक है, so when user click on submit st dot button submit and user input and create an initial state for the graph. Initial state equals to user input. Okay, the question I'm going to enter with the help of UI. So this is called the user input. Okay, and this is response AI will generate or tool will generate after some time. Okay, when I use UI. And memory equals to we are going to store memory in the session. Okay, and need tool equals to initially false. Okay, it may be changed when we need tools. Okay, loop count equals to st.session loop count. Okay, so this is for retry. If you have less than 3 loop count then you can retry, or like if you don't have satisfactory answer. Okay, so run the LangGraph here. Result equals to app.invoke. Here I pass this initial state and save the updated memory back to the session. So I save the memory inside the session result memory. Okay, and here also I also save the loop count inside the session is equals to result the loop count and show the response in the UI. Okay, response user response. Okay, sub header is response and st dot write result also response. Now you can see here chat history. This is our chat history. It is going to show you everything on UI. Okay, so chat history st dot session. Okay, st dot session underscore state memory. Okay, st dot subhead it is showing you conversation history. For I message in enumerate st dot session state dot memory. Here it is going to store user input message and response. Okay, so like ChatGPT it is going to show you past message and past response. Okay, one by one it is going to use loop here. Okay, and then store. So guys, I forgot one thing here. After okay, here after this LLM node I need to write one node also. Okay, So this one is this node. Okay, so this node is tool node. After LLM node we have another node, tool node. Okay, so user ask the question, then agent decide which node I need, sorry, graph decide which node I need to use, LLM node or tool. Okay, so this is the tool node. Okay, define tool node, I pass here state. Okay, and this is the frequency FAQs. Okay, frequency ask question. Here what are the FAQs, here are the FAQs. Okay, and help, how can I help you, and support, contact support.com. Okay, so this is the tool node, guys. Okay, so found initially it is equals to false for key and answer in the FAQs item. Okay, if key in state user input, तो यहाँ से हमें पता चल रहा है कि if these keys are present in the user input, okay, then state response equals to answer and found equals to true and then break. Okay, अगर यूजर के इनपुट में इसमें से कोई भी एक की मिला तो वो ये टूल यूज करेगा और यहाँ पर फाउंड इक्वल्स टू ट्रू होगा एंड देन ब्रेक कर देगा, यहाँ पर रिस्पॉन्स जनरेट करेगा. ओके ओके, अगर हमें यूजर का इनपुट है, यूजर इनपुट इन लोअर, आई मीन इट इज गोइंग टू कन्वर्ट इन लोअर केस एंड देन चेक if any key is present here, okay, then it will give you the response here. Okay, and found equals to true and then break. Okay, if key is not found, okay, so state it will give the response no FAQ match. Okay, and state memory dot append, it is going to append in the memory user input and response. Okay, user input and response of the user and return the state. State means I already show you flow of information, flow of the memory. Okay, and then we have satisfaction check. I already covered this satisfaction check. Okay, and then this is the graph, and then this is for chat history. Okay, then I need to save this. I'm going to open my terminal. Inside this, Streamlit run smart support underscore agent.py. Okay, and here so this is our smart support agent, guys. LangGraph press open router. I'm going to ask question, what is AI? So it is taking some time and it will give you the answer. So okay, so you can see here our server is running here. This is a Streamlit server. Okay, so it is giving us answer here. And guys, this is simple chatbot. Okay, whether it is going to use tool and whether it is going to use LLM, it will decide by the graph. Okay, so this is more powerful as compared to LangChain. Okay, so guys, you can see here I got the response. AI or artificial intelligence refer the simulation of human intelligence in machine that are. Okay, so this is the answer by giving this agent. Okay, and also conversation history, it is going to show you what is AI. Okay, and this is the response it is going to save here. Okay, you can ask any question. What is LangGraph? It is going to take some time. Okay, because it is slow here. I use model, this model. Okay, which model I use here? I hope you remember DeepSeek. Okay, this one I use this model DeepSeek. Okay, so it is giving us answer in LangGraph. it seems like you might be referred to the LangGraph term that could be associated with the language and graph-based technology, while LangGraph isn't widely recognized term in the mainstream AI. Okay, guys, so this is giving like answer, this kind of answer, and it is also saving what is AI, previous history, and what is LangGraph. Okay, and clarification needed. So LangChain or a popular framework building the AI. Okay, so this is giving answer. So hello guys, now I am going to create another project that is optional decision board. Okay, the file name is optional underscore decision underscore board. Okay, so this is our another project. So I mean this is a simple decision making board building using LangGraph. It helps us to take a decision like buying something or not, why or not, okay, by listing pros and cons and then giving a final recommendation. ठीक है, तो ये हमें it help us to take a decision like we want to buy something or not. Okay, and while listing pros and cons, or it is also list like हमें बताएगा कि क्या प्रोस है क्या कॉन्स है, एंड देन गिविंग द फाइनल रिकमेंडेशन कि हमें वो चीज़ बाय करनी चाहिए या नहीं. ठीक है, सो ये क्या करेगा, हमारी हेल्प करेगा डिसीजन मेकिंग में, जाकि ताकि हम कोई चीज़ खरीद रहे हैं उसको लेके उसके प्रोस एंड कॉन्स हमें बताएगा, हमें उससे क्या फ़ायदा रहेगा क्या नुकसान रहेगा, और हमें फाइनल रिकमेंडेशन भी देगा. ओके, सो यू कैन सी हियर आई इम्पोर्ट OS from .env. I am going to import load underscore .env, load.env. With the help of these three things we are going to access our OpenAI, sorry, Groq API key from .env file. Okay, so I have a Groq API key here. Okay, and then Groq API key, here you can see read the API key os.getEnv Groq API key. Okay, I'm going to run this, and after this install if needed. Okay, I already installed these things, LangGraph, LangChain -Groq. Okay, if you don't have, you can install it. Okay, you need to uncomment this. So from LangChain.graph I am going to import state graph and okay, so here I'm going to import this. Okay, from LangChain underscore Groq import the chat Groq. Okay, this is for access the Groq model. Okay, and import the OS, and from typing import the type dict for data validation. Okay, and list here. So define the state properly. So here class equals to decision state. Here I pass the type dict. With the help of type dict we can define the data type. Decision should be in string. Pros should be in list of string, and cons should be in list of string, and analysis should be in string, and recommendation should be string. Guys, these are the parameter I'm going to use. Okay, so here like this is the simple word like give you the recommendation or pros and cons of the what you are buying or not. Okay, so if you're buying for laptop, so it is giving you the pros and cons and recommendation. Okay, so here we are going to use LangGraph. So here I already have import the LangGraph things. Okay, so we using LangGraph to break the problem into the steps. So instead of doing everything in one block, the program follows like multiple steps here. Okay, so it first collect the pros. It is going to first collect the pros and then collect the cons and final compare them to decide yes or no's. Okay, so basically it simulate how the human think in a very basic way. What this by using this code. Okay, so हमें यहाँ पर पहला वो क्या करेगा, पहले कलेक्ट करेगा प्रोस एंड देन कॉन्स. ओके, एंड देन फाइनल कंपेयर करेगा और डिसाइड करेगा कि तुम्हें वो खरीदना चाहिए या नहीं प्रोडक्ट. ओके, सो हमने यहाँ पर कुछ चीज़ें लाइब्रेरीज इंपोर्ट किया. आई हैव इंपोर्ट some libraries from LangChain Groq. Okay, and from typing, and then this is our state. Okay, state in LangGraph we have first thing that is decision state. Okay, so this is our first class. So you can see here I use this one, state graph. So state graph and end from the LangGraph. Okay, and chat Groq LLM wrapper from the Groq API. And means represent the end state, okay, of the graph, last state, and represent the end state of the workflow. Okay, and OS module to access the environment variable like API key. Okay, and type dict and list, you can see here type dict is used to define the structure dictionary state format. Okay, and list is used for type hinting list like list of string. Okay, like this. So after this we define the state structure, this one. Okay, so this is the class, and here I pass here type dict. So this class define the memory of the workflow. Every steps will read and update this state. Okay, this define the memory of the workflow, and every step nodes will read and update this step. Okay, now we have pros and cons. First we need to gather the pros, so I have code here for gather the pros and cons. Okay, we have these two nodes. फर्स्ट नोड हमें बताएगा कि कितने प्रोस हैं कितने कॉन्स हैं, एंड सेकेंड नोड बताएगा, सॉरी फर्स्ट नोड बताएगा प्रोस. ओके, so this is our first node. Gather the pros. Here I pass this state. State means flow of memory. State equals to decision state. Okay, and here state pros. So हमें यहाँ पर pros निकाल रहे हैं, benefit 1, benefit 2, benefit 3, and return the updated state. Okay, so here gather the pros. Okay, with the help of this we will get the pros. This function add the advantage to the state. Okay, so I got the benefit 1, benefit 2, benefit 3 like this. Okay, and return the updated state here. That's it. Okay, now we have another function, that is gather cons. Here I also pass this state. Okay, decision state, and cons equals to drawback 1, drawback 2, and return the updated state here. Okay, so count the number of the, it is going to count the number of the pros. Sorry, it is giving us like gather the pros and gather the cons here. Okay, after this we are going to analyze how many like cons we have and how many pros we have. Okay, so we need to use analyze decision. This is another node. Okay, okay, after gathering the pros and cons, we have another function, analyze the decision. Okay, so analyze the decision, this one. Okay, so here I pass the again state, this one, decision state. Okay, pros count length of pros, and cons count length of cons. Okay, so it is going to count number of the pros, first line number of the pros and number of the cons. These are going to count the number of pros and number of the cons. Okay, if pros count is greater than cons count. Okay, तो हमारे जो प्रोस हैं, मतलब जो हमें किसी चीज से लाभ हो रहा है, उसके जो डिसएडवांटेज से ग्रेटर देन है, तो इट विल रिकमेंड दी yes. Okay, it will recommend the yes. Simple logic, guys. Compare the pros and cons here. Okay, if pros is greater than cons, then it will recommend the pros. Okay, otherwise it will going to recommend the cons. Okay, that you don't need to why this, it is saying no. Okay, so here more cons means more disadvantage, more cons means more disadvantage. So it is showing like recommended, like there is no need to buy, no recommendation. Okay, recommendation equals to no, and here recommendation equals to yes, because cons is greater than, sorry, pros is greater than cons here. Okay, so here state analysis, you can see here create the final explaining string. Okay, so pros equals to pros count and cons equals to cons count. Okay, and recommendation here it is giving us recommendation that I need to buy or not, so it is giving us yes or no. Okay, and written the updated state here. Okay, and then I have graph, so I'm going to build the graph. So here you can see I'm just going to take code from here for building the graph. Okay, so here after this we are building our graph here. Graph equals to state graph. I pass here decision state. This one. Okay. And graph dot add underscore node. I pass pros. Pros node means gather in pros. So I pass this node here and then this graph cons and then analyze decision. So मैंने तीनों नोड को यहाँ पर कनेक्ट कर लिया ग्राफ से. So this is for object for graph for creating the graph. Graph equals to state graph. I pass this decision state for memory. Okay, flow of memory. So graph dot add node. I'm going to add gather the pros and gather the cons and एनालाइज द डिसीजन. तो मैंने यहाँ पर तीन हमने फंक्शन बनाए थे. these all three, gather pros, gather cons and analyze decision. I'm adding here. And graph dot set entry point. First one is gather the pros is entry point of graph. Okay, so this one is the starting point of the workflow. And here graph dot add edges. So here I'm going to connect pros with cons. Okay, with the help of edges. Now graph dot add edges, I'm going to connect coins with analyze. Okay, and graph dot edges add edges, analyze, and then end here. Okay guys, so you can see here this is our starting point. Okay, starting point of the workflow. And then here you can see pros is going to the cons. Okay, pros go to the cons and here cons go to the analyze. And analyze, after analyzing, stop the workflow with the help of end here. Okay, stop the workflow here with the help of end. Okay, now we are going to compile the graph. So here we can compile our graph. Okay, so compile the graph. App equals to graph dot compile, result equals to app dot invoke. Okay, so this convert the graph into an executable application. Okay, so here you can see this convert the graph into an executive application. So app equals to graph dot compile. So here we are going to run, and here we have one variable, result equals to app dot invoke. I pass decision for buy the laptop and pros and cons and analyze and recommendation. Okay, so print the result analysis. So हम वैसे पूछ रहे हैं कि हमें लैपटॉप बाय करना चाहिए या नहीं चाहिए. So it is giving us the answer. Okay, it is saying pros equals to 3, cons equals to 2 and recommendation equals to S. तो आप खरीद सकते हो क्योंकि pros 3 है. Okay, pros is 3. So here we can see 3 pros and 2 cons. Okay, so 3 pros and cons are 2. So the system are recommended S. Okay, so that means based on simple logic buying the laptop makes sense. Okay, so the graph compare pros and cons, and since pros are greater than the cons, the final output is recommendation S. Okay, so more pros, more cons, more pros than cons, the decision is S. This is the simple root-based system, not the real AI reasoning, just structured decision logic. Okay guys, so you can make decision like this with the help of LangGraph. Okay, so here now I'm going to create third project, optional research underscore agent dot ipynb. Okay, I'm going to close this left sidebar. Okay, so this is our project, multi-step research agent. So we are going to build an agent that break the query into small sub question and search and summarize. Okay, so this agent break a big question into a smaller sub questions. Okay, and search each one and then summarize everything. Okay, so here I'm going to import OS. Okay, so it is used to access the environment variable like API keys. Okay, and from .env I'm going to import load.env, load the variable from .env file. Okay, and this one also used to load the environment variable from .env file. Okay, and this one Groq underscore API key os dot get env. Here we can access the API key with the help of .env file. Okay, so read the Groq API key from the environment. Okay, and after this import the LangChain here. Okay, so I'm going to paste something here, guys. Okay. Mm, okay, so you can see here I'm going to import state graph and end from LangGraph dot graph. Okay, so here state graph means build step by step workflow, and means marks end of the workflow. Okay, and here you can see I have one class research under research state. Here I pass the dictionary and pass. Okay, so we use a simple dictionary as a state here. We use simple dictionary as a state here. It store everything the agent needs while moving through the step. It store everything the agent need while moving through the steps. Okay, so this is our first class research state, and here we have nodes node breakdown query. So this is our first node, that is break down the query. I pass here state. Okay, so here sub question. Okay, so this function take a big query, this function break down the query. So this function take the big function, okay, big query, and split into a smaller question. Okay, state sub question equals to what is query and history of the query and current trends of the query. Okay, so it is going to split big query into a small piece of the query with the help of what is the query and history of the query and current trends of the query, and update the state. Okay, and then you can see we have another search state. This is another function search step 1. Okay, so the question is take the first sub question. Okay, state sub question, first question. Okay, so it is going to take the first sub question. You can see here zero index means first sub question. Okay, and here it is giving us answer like simulate the answer for question state answer. So here you can see append the answer inside the answer. Okay, so this one take the second sub question. No, this is take the first sub question. Okay, and then you can see here simulate a search result, no real AI search used here. Okay, so यहाँ result search करेगा, AI use नहीं कर रहा. And here store the answer in the answer list. Here state answer dot append answer and return the updated state. Okay, after this we have another one. Actually I finished search 1, search 2, and then we have search 3, these two. So you can see here in search 3, this is another function. I pass here state. Okay, so this function. Okay, search 2, no, search 3. Where is search 2? Search 1, search 3 is here, but where is search 2? 1 minute, guys, I need to mention search 2 also. I'm going to take from here to here search 2. Okay, so you can see here after search 1 we have search 2 question. It is going to take question. Okay, take a second question. Okay, second sub question. You can see here previously I take first question, and now it is going to second question because I have index equals to 1 here. Okay, and then it is giving answer. Okay, simulate the answer for the question. Okay, and then append this answer into the answer and update the and return the update state here. Okay, and save the result here inside this. Okay, and in step 3 node 3, this is our node 3 search 3. Okay, so we are going to take question like second question, third question, first, second, third. Okay, because I have index equals to 3. Okay, so here this is the question, take the second sub question here. Okay, and then generate the answer here. Okay, and giving the answer here. simulated the answer and saved the answer inside the answer and return the updated state. Okay, and then this is our final fourth node, search step 3. Okay, so take the third sub questions. Okay, summary equals to summary dot join state answer. State equals to, here it is giving us final answer equals to summary and return the state. Okay, so it is going to like take the third sub question here inside this, and this is the for summary. Okay, this is used for summary, this one, summarize answer state. Okay, so this is used to combine the all collected answer into the final one summary. Okay, so summary equals to summary, it is showing the all the state answer. Okay, it is going to take the answer from here and here. इसने सब जगह से आंसर उठा लिया, सर्च 1 सर्च 2 सर्च 3 से, और उसको मर्ज कर दिया विद द हेल्प ऑफ ज्वाइन, एंड देन इट इज गिविंग अस द फाइनल समरी एंड रिटर्न द updated state here. That's it, guys. Okay, and after this I need to create one graph. Okay, so here graph equals to graph. Here I pass the dictionary. This is the instance of graph. When we are going to create, then we need to write like this, graph equals to state graph. Here I need to use dictionary. Okay, so create a graph using a dictionary with state. Okay, so graph dot add nodes. I'm going to add the node breakdown query. Okay, so first node, this one, break down the query in sub questions. Okay, big query break down into a small question. Okay, then search 1 search 2 search 3, we have different nodes, and analyze the summary also, we have this node also. So we are going to add node one by one. Okay, graph dot add node, add node, add node, add node. So break down, this is the first node, and then search 1 search 2 search 3, and summarize the answer. So these are the nodes I'm going to add here. I'm giving here one name, breakdown equals to, this is the node name, search 1 equals to, this is the node name, search 2 equals to, this is the node name, search 2. Okay, and these are the function name. Okay guys, that I have created here, node 1 search 1 search 2, and summarize the answer. Okay, now we are going to set the entry point of the graph. Okay, so breakdown big query into smaller query, this is the entry point of the graph, this one, this node, this one. Okay, and then I'm going to connect search 1 here, breakdown with search 1 here. Okay, so after entry point we are going to connect step 1 with step 2. Okay, then step 2 is going to connect with step 3, step 3 is going to connect with step 4. Okay, fourth step, now we are going to summarize here. Okay, so this is the final summary here, and then end the workflow here. After giving the summary, it is giving the end of workflow. Okay, it is going to end here. Okay, and then what? And then we need to compile our graph. F equals to graph dot compile this whole graph. Okay, and result equals to f dot inbox, query equals to AI, sub question is empty list, answer is also empty, and final answer is also empty here. Now print the result, and here I put here final answer. Okay, this one. So here you can see here. Okay, so this is the summary. Simulate the answer for what is AI, simulate the answer for history of AI, and current trends in AI. Okay, so the agent break the main question into small sub question and get the answer for them and combine them into a final summary. Okay, so big question, here you can see big question break into smaller question, and then answer, and then final summary. This is big question, guys. So guys, you can see here the agent break the main logic into the sub questions, generate the answer for each of one and then combine them into a final summary. Okay. So first it split the query into smaller question like definition, history and trend. Then it process each one step by step and collect the result into the final summary here. Okay. So this is simulated version of the research agent in a real system. Each answer would come from a search engine or a LLM, not the hard-coded text. Okay, so big question, smaller parts of question, and then okay, big question, small answer part, and combine them into a final. Big question convert into a small part of question and then answer, and finally it will generate the final summary here. Okay. So guys, this is the code for creating the big question into a this break big question into a small sub questions. Okay, this is for break down the query. This is for search one. This is for search one is used for this one. Okay, this is search one step, and this one is used for search two. Okay, and this one is used for search 3, and then analyze and combine the result here and then generate the summary. Okay, then I have create the graph and connect the edges and nodes here. Okay, and then compile the graph and return the result here and print the result here. Okay, so hello guys, now I am going to create another project number 4, AI story viewer .py. Okay, so this is the file I'm going to create here, project. Okay, I'm going to close this sidebar, and now I'm going to import some important library that I already use in every project. Okay, so I'm going to copy from somewhere. I need to go here, and then I need to copy these things. Okay, so this project like writing the story for you, that's it. This is simple. Okay, like it is also going to ask like what kind of a story you want to generate. Okay, like mysterious or horror, something like this. Okay, so here you can see I'm going to import uh, Streamlit LST. Okay, so Streamlit library for building the web UI. Okay, and then I import state graph and end. So LangGraph, from LangGraph dot graph import the state graph and then end. So LangGraph for building the workflows. Okay, workflow graph, so that's why I use this. And from LangChain underscore OpenAI I'm going to import chat OpenAI. Okay, so no, I'm going to import LangChain. In place of OpenAI, I need to import Groq because I'm going to use Groq API. Okay, so Groq import here chat Groq. Okay, so this should be Groq. Okay, so this one LLM wrapper to use the Groq model by LangChain. Okay, and from .env I'm going to import load underscore .env. Okay, so load the environment variable from .env file, and here I import this one. I think it may be used or not, so I'm going to remove just now. If need, then I will use it. Okay, and import the OS. Okay, so used to access the system environment variable with the help of this. Okay, and now from this file I'm going to import load underscore .env, this one. Okay, and then I'm going to import os.get maybe os.get environment. 1 minute, maybe I have. Okay, let me check here in first file. this line. Okay, I'm going to use here os.getEnv Groq API key, and here also I need to paste it, and in place of this, okay, os dot environment variable, here Groq API key equals to os dot getEnv Groq API key. Okay guys, if you don't have Groq API key, you can go there in Groq website and you can create your own API key and put your Groq API key here inside this env file. This is for example, you can put here your own API key, and this is the variable name for API. Okay, so after this one is used to store the Groq API key into the environment variable, so chat Groq can use it. Okay, now I'm going to create code for UI. So I already have UI code. So this is the UI code. I'm going to copy and paste it here. Okay, so set st.page underscore config. So this is the page title, AI story viewer. Okay, and page icon, this one. So this is the title, AI story viewer with the help of Streamlit. St means Streamlit.write, create the story step by step with AI. Okay, and gen equals to st.select box. Okay, choose gen. ओके, लाइक फैंटेसी, साई-फाई एंड मिस्ट्री. तो आपको यहाँ पर स्टोरी का टाइप चूज करना पड़ेगा कि आपको किस टाइप की स्टोरी, व्हाट काइंड ऑफ लाइक स्टोरी यू वांट टू जनरेट हियर, फैंटेसी, साई-फाई एंड मिस्टीरियस. ओके, सो चैप्टर लिमिट इक्वल्स टू st.slider नंबर ऑफ चैप्टर 153. ओके, so after this, okay guys, so this is the main title. Okay, AI story viewer, and this one short description under the title. Okay, and this one is short description under the title. Okay, and this is the main title, AI story viewer, and this is the page title. Okay, and drop down select for the story genre. Okay, this one, and this one slider to choose under of the chapter 1 to 5, default 3. Okay, and now after this we have states. So I'm going to take code from here. State, I'm just taking all the steps here, states, not a step. Okay, so you can see here graph states. So I'm going to, okay, so this is the state. So you can see here state. So function, this is the function init state. Here I pass the state. The function to initialize the state before story generation start. Okay, so function to initialize the state before story generation start. Okay, so this is the function to initialize the state before story generation start. Okay, so here I give the chapter 1, sorry, chapter equals to 1. So start chapter count at the 1 with the help of this. Okay, so dimension in the comment, start with chapter 1. Okay, and then in this line we have story equals to genre. Here you can see, so it initialize the story text with the genre header. Okay, so story equals to, we are going to choose this kind of like fantasy, sci-fi, mystery. Okay, and then return the updated state. Okay, so here it is going to return the state. Okay, now after one state, Here you can see this is the another function generate. Okay, here I pass the state. So function that generate the story content using the LLM. Okay, this is the function. This is the function generate function that generate the story content using the LLM. LLM equals to chat Groq model equals to llama 3.1 8 billion instance. Okay, instant prompt equals to write the chapter. Okay, write the chapter. So here I load the model. Okay, load the Groq model, LLM model, and here this is the prompt sent to the model. Write the chapter. Okay, so chapter of a state and then a story. Okay, so this is the prompt I'm going to send to the model. I use chapter here as an input and gen as an input. Okay, and a story so far. So this is going to generate the giving the story and giving the idea, taking the idea from the user. Okay, so user idea this one and a story for this one. Okay, and this is for generate the LLM response. So response equals to llm.invoke prompt. ओके गाइस, दिस इज द यूजर इनपुट, ठीक है। और यहाँ पर स्टोरी का टाइप है क्या नहीं है। और यहाँ पर जो चैप्टर है, चैप्टर 1 चैप्टर 2 लाइक दिस, इट इज स्टार्ट फ्रॉम 1। ओके, यहाँ पर भी जो स्टोरी का टाइप है उसके बेस पे दिस इज द प्रॉम्प्ट, हम क्रिएट कर रहे हैं प्रॉम्प्ट। ओके, तो हमें मॉडल को हमें प्रॉम्प्ट दे रहे हैं, उसके साथ हमने चैप्टर दिया और स्टोरी का टाइप दिया कि किस टाइप की स्टोरी हमें जनरेट करवानी, लाइक मिस्टीरियस, ओके, साई-फाई, वट एवर। ओके, तो यहाँ पर हम प्रॉम्प्ट दे रहे हैं इस मॉडल को ताकि वो स्टोरी जनरेट कर सके। तो रिस्पॉन्स इक्वल्स टू llm.invoke prompt। आई एम जस्ट गिविंग this prompt to the llm.invoke with the help of this llm.invoke। I am giving this prompt to the model। okay, then append here after this state story। so there append the generated chapter to the story। okay, so in story I'm going to append generated chapter। okay, so append generated chapter to the story। ओके, सो हियर यू कैन सी इन स्टोरी हमने जो जनरेटेड चैप्टर था और जो रिस्पॉन्स था उसकी हेल्प से हमें यहाँ पर एक स्टोरी मिली। एंड देन अपडेट दी स्टेट हियर। ओके, रिटर्न दी अपडेटेड स्टेट हियर। ओके, एंड हियर फंक्शन टू मूव द नेक्स्ट चैप्टर। ओके, chapter increase by 1 with the 1। okay, so increase the chapter number and return the updated state here। okay, so guys, like this is the first function for state and this is for generate the state। okay, and here update the state, nothing else। now we are going to create graph। I'm going to take from here session to graph। so guys, I'm going to create graph। we are going to initialize our graph state with the help of dictionary। okay, so here create a state machine graph using the dictionary as a state type। okay, so हमने यहाँ पर node ऐड की। we are going to add the node with the help of add underscore node in the graph। okay, so graph dot add a node, graph dot add a node। so first is init state। okay, so this is our first node, then generate our second node and this one is third node। okay, so हमने यहाँ पर तीनों नोड को कनेक्ट कर लिया, init stage, generate and then update। okay, एंड हमने एंट्री पॉइंट सेट कर दिया ग्राफ का, सेट अंडरस्कोर एंट्री अंडरस्कोर पॉइंट, दैट इज फर्स्ट नोड। ओके, इनिट स्टेज दिस वन। ओके, एंड देन हमने एक एजेस, अब एजेस को कनेक्ट कर रहे हैं ग्राफ की। सो वी आर गोइंग टू कनेक्ट दी एजेस ऑफ द ग्राफ। सो हमने यहाँ पर इनिट को जनरेट से कनेक्ट किया, जो इनिट वाला नोड है इसको हमने इससे कनेक्ट किया। ओके, विद द हेल्प ऑफ एजेस। सो जनरेट init generate here। okay, so init connect with the generate and generate is going to connect with the update and then update and then stop the execution here। okay, then app equals to graph dot compile the graph into runnable app। okay, and then session, if session not in session dot st dot session state। okay, st dot session underscore state dot state equals to none। so initialize the session state if not already present। Okay, now we can see here after session, this is going to store the session. Okay, start the flow fix. So here this is for user import. User import equals to st dot text import. Start your story idea, what should happen first. Okay, तो यहाँ पर आपको स्टोरी आइडिया डालना पड़ेगा, किस टाइप की आपको स्टोरी चाहिए. एस टी डॉट बटन स्टोरी स्टार्ट. जब आप बटन पे क्लिक करोगे एस टी मतलब स्टोरी जनरेट होना स्टार्ट हो जाएगा. ओके, जब आप यूजर इंपोर्ट करोगे यहाँ पर. ओके, so here button to start the story generation. Okay, and then create the initial state dictionary for the graph. State equals to I pass here gen and chapter and story is empty here क्योंकि अभी generate नहीं हुआ, story generate होगा तो यहाँ आ जाएगा. And user import equals to user import. Okay, now input come first. Okay, and result equals to f dot invoke. Here I pass the state. Okay, so this one run the graph with the initial state, and this one stored the result in the session so UI remember it. Okay, so st dot session underscore state and dot state result. Okay, and then display. Okay, then display the result. Okay, if ft dot session underscore state dot state, if story exists in session state display it. Okay, so story st dot session and underscore state under dot state and here story. So it extract the story text. It is going to store extract the story text, and in text or st dot text area it is giving us story. Okay, story minus 1000. Okay, so the last 1000 character of the story in the text area. यहाँ पर ये क्या करेगा, विद द हेल्प ऑफ दिस स्टोरी शो करेगा यूआई पे, जो कि लास्ट 1000 कैरेक्टर आपको शो करेगा in the text area. Okay, and height उसकी 300 रहेगी, nothing else. Okay, so next input equals to st dot text input. Here what happened next. Okay, so यहाँ पर आपको कुछ next input देना है तो you can give. Okay, next input for continuous the story. So button, you can see here button to generate the next chapter. Okay, ताकि आप next कुछ पूछ सको. And here update user input for the next generation. st dot session state user input next input. Okay, and result equals to f dot invoke st dot session underscore state. So this one is giving us the result. Okay, so run the graph again with the updated state and provide the result here, and the save the updated result here. So st dot session dot underscore state and then result and return the rerun. Okay, so this rerun Streamlit tab to refresh the UI. Okay, and this one used for save the updated state. Okay, and this one is used for run the graph again with the updated state, and this line is used for user input for the next generation. Okay, I'm going to save this. I'm going to create terminal. Okay, now we can run. So Streamlit run AI story file name. Okay, so I got this UI. Okay, so you can see here we have genre fantasy is sci-fi and mystery. Okay, आप इसमें से इन टाइप की स्टोरी जनरेट करवा सकते हो, या फैंटेसी टाइप, मिस्टीरियस टाइप, साई-फाई टाइप. ओके, so here you can choose the number of chapter, how many number of chapter you want. Okay, and start your story idea, what should happen first. Okay, so हमने यहाँ पर एक कोड लिखा था, this one, last one, this is for next chapter guys. Okay, next input equals to what happen next. Okay, so आप यहाँ पर next idea के लिए यहाँ पर and now we can input some story ideas. Okay, So here a phone receive alarm from the future, but the future keep changing every time you snooze. So this is the idea I'm going to put here. Start the story. Okay guys, so the world will end in 48 hours, the alarm read. I set up my heart racing. This was it. This was the moment of truth. I had to do something, but what? I started at the phone, my mind racing with response possibilities. Was this the end of the world as we knew it, or what? It just another alarm, another red herring. Okay, guys. So this is the story. It is generated by the. You can write here like next thing what you want. Okay, so you can put another a city where anyone who lies start glitching physically, like reality can't render them properly. Okay, so you can put your ideas and this will generate the story for you. Okay, guys, you can create like big project and you can select mysterious and I'm going to run again. You can see here it is going to run. So yeah, it is giving us like here. Okay, at young man, his body beginning to glitch as he spoke, sting of out land is lie his face. So guys, this is like a story. Okay, you can read this. Okay, so this is generated the story by this tool. So this is like a story generate tools. You can give your idea and it will generate. Okay, and you can also improve the output of this. Okay, if you want to improve and if you want to add the like other language, then you can also add the language. Like if you want answer in Marathi, Hindi, Bengali, Kannada, Telugu, Tamil, etc., so you can use any of one. Okay, you can improve this code. This is just for demo purpose, nothing else, and for learning purpose. So this is our code for uh, LangGraph for a story writer. Okay, so guys, thank you. Bye bye. I have completed this video. This is the crash course of LangGraph. If you like my video, please do like, comments and subscribe. Bye bye.